Welcome to the Ultimate Data Governance Analyst Interview Scenarios Series.
The most comprehensive data governance analyst interview preparation series on YouTube for 2026 and beyond interviews. Whether you're targeting data governance analyst, senior analyst, or lead roles, with 2 years or 10+ years of experience, this series is built specifically for you.
What to expect?
In this 3-part mega series, I've compiled 426 real-world, high-impact scenarios that are actually being asked in interviews right now by top companies, from FAANG and big tech to banks, healthcare, and fast-growing startups. These aren't basic theoretical questions. These are tough, strategic, AI-powered, and executive-level scenarios that separate candidates who get rejected from those who receive strong offers.
Series breakdown.
Here's what we're covering across the 3 parts. Part 1, this video, fundamentals and core pillars, data strategy, data quality, metadata, master data, privacy, compliance, cloud governance, lineage, stewardship, and security. Part 2, AI and modern governance scenarios, Gen AI governance, RAG security, data mesh, modern platforms, industry-specific scenarios and tools. Part 3, executive, hyper-modern and wildcard scenarios, board-level questions, 2026 plus future state challenges, data clean rooms, EU AI Act, monetization, and surprise questions. Every single scenario comes with a clear answer plus a real-world pro tip, battle-tested insights you won't find in books or standard courses.
By the end of the series,
You won't just be prepared, you'll be dangerously prepared, ready to walk into any interview with confidence and stand out from the competition. So if you're serious about landing or leveling up in a data governance role in 2026 and beyond, smash that like button, subscribe, and let's dive straight into Part 1. Part 1, fundamentals and core pillars related scenarios. Hey everyone, welcome to Part 1 of the Ultimate Data Governance Analyst Interview Scenario Series for 2026 and beyond. In this part, we will cover all the foundational and core topics related scenarios that form the backbone of any data governance analyst role. Every scenario comes with a clear answer and a powerful real-world pro tip. Let's get started. Categories covered in Part 1.
Part 1, fundamentals and core pillars.
This part includes the following categories. Category 1, enterprise data governance strategy scenarios, 20 scenarios. Category 2, data quality scenarios, 25 scenarios. Category 3, metadata management scenarios, 20 scenarios. Category 4, master data management MDM scenarios, 15 scenarios. Category 5, data privacy and compliance scenarios, 25 scenarios. Category 6, cloud and modern data platform scenarios, 20 scenarios. Category 7, additional core scenarios, lineage, stewardship, security, architecture, and BI 20 scenarios. Total 145 scenarios in Part 1.
Category 1, enterprise data governance strategy scenarios.
We start with the most important and frequently asked category in interviews, enterprise data governance strategy. These scenarios test your strategic thinking, ability to align with business objectives, and your understanding of governance operating models.
Category 1, enterprise data governance strategy scenarios.
Here are the 20 scenarios covered in this category. Scenario 1. Your organization has 14 disconnected business units using different definitions for active customer. Executive leadership wants a single enterprise KPI within 90 days. Scenario 2. A newly appointed chief data officer asks you to design a governance operating model for a company with no existing governance structure. Scenario 3. Your company acquires 3 startups, each with different data policies, classification models, and retention standards. Scenario 4. The board asks for measurable ROI from the data governance program after investing millions over 2 years. Scenario 5. Business leaders claim governance slows innovation. You are asked to redesign governance to support AI product delivery. Scenario 6. A global enterprise wants to decentralize governance using a data mesh architecture while maintaining enterprise control. Scenario 7. Your company is migrating from project-based governance to product-based governance. Scenario 8. The CEO wants governance KPIs tied directly to business revenue and customer trust metrics. Scenario 9. Multiple governance councils exist but constantly conflict over data ownership. Scenario 10. The company wants to implement governance in agile squads instead of centralized governance teams. Scenario 11. A governance program failed previously due to lack of adoption. You are hired to relaunch it. Scenario 12. Leadership wants governance embedded directly into DevOps and CI and CD pipelines. Scenario 13. Your organization has strong governance policies but zero enforcement. Scenario 14. Governance maturity differs heavily between departments. Finance is mature, marketing is chaotic. Scenario 15. Executives want governance automation using AI agents. Scenario 16. A multinational enterprise wants one governance framework that works across 40 countries. Scenario 17. The company wants governance integrated into digital transformation initiatives. Scenario 18. Your organization wants to benchmark governance maturity against competitors. Scenario 19. A company wants to transition from traditional governance to active metadata-driven governance. Scenario 20. Leadership asks whether governance should remain centralized or move to federated ownership. Total 20 scenarios.
Let's start.
Without further delay, let's dive into Scenario 1.
Scenario 1. Your organization has 14 disconnected business units using different definitions for active customer. Executive leadership wants a single enterprise KPI within 90 days. How do you handle this?
Answer: to align 14 disconnected units and deliver a unified KPI within a strict 90-day window, I would execute this high-velocity strategy. 1. Implement a semantic layer. Use tools like dbt or Atlan to map BU-specific definitions to a central golden KPI in the data warehouse. 2. Nominate a tie-breaking committee. Select lead data stewards from the top 3 revenue-generating units to finalize the master definition logic. 3. Deploy AI-assisted mapping. Use Gen AI to analyze existing SQL scripts across all 14 units to find the most common logic denominators automatically. 4. Establish local aliases. Standardize the enterprise KPI while allowing BUs to keep their local definitions for specific operational nuances. Pro tip: do not fight over definitions in meetings. Use a headless BI approach where the metric is defined once in code and push to all BI tools simultaneously to ensure a single version of the truth.
Scenario 2. A newly appointed CDO asks you to design a governance operating model for a company with no existing structure. What are your first steps?
Answer: designing a model from scratch requires a foundation built on accountability and modern automation. My first steps would be: 1. Identify domain owners. Map critical business processes to data creators to establish clear accountability from the start. 2. Establish a federated council. Assemble a group of business and IT leads to set cross-functional data policies and priorities. 3. Deploy minimum viable governance. Focus initially on metadata and security to meet legal requirements before tackling complex DQ rules. 4. Select active metadata tools. Implement a catalog that supports automated discovery and classification to reduce manual effort. Pro tip: start with data privacy or security compliance first. Legal requirements like the EU AI Act have teeth and will secure you an executive budget much faster than a generic plea for better data quality.
Scenario 3. Your company acquires 3 startups, each with different data policies, classification models, and retention standards. How do you integrate them?
Answer: to mitigate risk during post-merger integration, I would execute this 4-pillar standardization strategy. 1. Policy crosswalk. Compare all 3 startup policies against the parent company standard to identify and prioritize high-risk gaps. 2. Unified classification. Map disparate tags such as confidential versus private into a single global tagging schema. 3. Retention sweep. Audit the startup's cloud storage to identify and purge legacy data that exceeds legal retention limits. 4. Automated discovery. Deploy AI-driven scanners to verify if startup environments contain PII that was not declared during due diligence. Pro tip: conduct a dark data audit in the first 30 days. Startups often have forgotten S3 buckets or dev databases. Finding these shadow systems early prevents massive future security and legal liabilities.
Scenario 4. The board asks for measurable ROI from the data governance program after investing millions over 2 years. How do you respond?
Answer: I would pivot the conversation from compliance to operational efficiency and FinOps. I would demonstrate ROI by showing the hard dollar reduction in cloud compute costs achieved by purging redundant datasets, the thousands of engineering hours saved through automated data discovery, and the revenue lift generated by improving the accuracy of customer profiles used in high-value sales campaigns. Pro tip: tie governance metrics directly to cloud waste. Use active metadata to identify unused pipelines and ghost tables to show the CFO an immediate reduction in your monthly Snowflake or Databricks bill.
Scenario 5. Business leaders claim governance slows innovation. You are asked to redesign governance to support AI product delivery. What is your narrative?
Answer: my narrative is that governance is the accelerator, not the brake. In the age of AI, moving fast with bad data leads to expensive hallucinations and legal liabilities. I would redesign the model to shift left, embedding automated data quality and bias checks directly into the developer's CI and CD pipelines, allowing them to innovate safely without waiting for manual board approvals. Pro tip: replace manual review meetings with data contracts. If a developer's code passes automated schema and quality checks in the pipeline, they get an auto approval to deploy, turning governance into a self-service feature.
Scenario 6. A global enterprise wants to decentralize governance using a data mesh architecture while maintaining enterprise control. How do you design this?
Answer: in a data mesh, the goal is to federate accountability while centralizing the technical standards. I would structure the design as follows. 1. Federated computational governance. Define global standards that are enforced automatically via code across all platforms. 2. Domain-driven ownership. Shift responsibility for data quality and documentation to the specific teams that produce the data. 3. Self-service platform. Provide a central governance as a service portal so domains do not have to build their own tools. 4. Enforce data contracts. Implement strict schema and quality agreements between data producers and their internal consumers. Pro tip: in a mesh, the central team should stop writing PDF policies and start writing policy as code using OPA or Rego. This allows you to enforce global rules across 50 domains without ever needing to attend their meetings.
Scenario 7. Your company is migrating from project-based governance to product-based governance. What does this change mean?
Answer: this is a shift in mindset where we stop treating data as a byproduct of an application and start treating it as a standalone product. This means every dataset now has a data product manager responsible for its uptime, quality, and documentation. Governance moves from a periodic check-the-box exercise to a continuous lifecycle management process that treats data as a high-value asset. Pro tip: create data product SLAs. Just like software has an uptime SLA, a data product should have a quality SLA. If the SLA is breached, it is treated as a production incident, ensuring it gets fixed with the same urgency as a system crash.
Scenario 8. The CEO wants governance KPIs tied directly to business revenue and customer trust metrics. How do you link them?
Answer: I would link revenue to data completeness showing that when customer profiles are 100% accurate, upsell conversion rates increase by X%. For customer trust, I would track privacy fulfillment latency, measuring how quickly we handle right-to-be-forgotten requests. Proving our governance maturity directly protects the brand and reduces legal exposure. Pro tip: focus on privacy debt. Measure the total dollar value of sensitive data sitting in unencrypted legacy systems. Reducing this debt is a direct metric for increasing customer trust that the board will understand instantly.
Scenario 9. Multiple governance councils exist but constantly conflict over data ownership. How do you resolve this?
Answer: conflict usually arises from a lack of clear decision rights. I would implement a RACI matrix at the data subject level rather than the council level. I would define primary stewardship based on who creates the data versus who derives the most value from it, and establish the CDO as the final arbitrator for cross-functional disputes. Pro tip: use a tiebreaker rule based on the source of truth. The business unit that owns the system of record, where data is first captured, always has the final vote on the definition, while others remain as consulted stakeholders.
Scenario 10. The company wants to implement governance in agile squads instead of centralized teams. How do you execute this?
Answer: transitioning governance to agile squads requires embedding standards into the sprint lifecycle through these 4 actions. 1. Appoint data champions. Embed one trained governance lead within each agile squad to represent data standards in every sprint. 2. Governance user stories. Include data documentation and PII classification as mandatory definition of done DoD criteria. 3. Automated guardrails. Use linter tools to ensure that any new database table created by a squad follows enterprise naming conventions. 4. Monthly community of practice. Hold cross-squad meetings to share learnings and ensure decentralized teams are not drifting apart. Pro tip: do not call it governance inside squad meetings, call it data debt management. Developers hate bureaucracy, but they understand technical debt. Frame governance as the way to prevent debt from slowing down their next sprint.
Scenario 11. A governance program failed previously due to lack of adoption. You are hired to relaunch it. What is your roadmap?
Answer: to overcome the stigma of a failed program, the relaunch must focus on high-impact enablement rather than restrictive policing. 1. Identify bureaucratic friction. Conduct interviews with business leads to identify exactly where the previous program was too slow or complex. 2. Target high visibility wins. Fix a critical pain point, such as the CEO's primary revenue dashboard, to gain immediate trust and sponsorship. 3. Market as AI ready. Rebrand the program as an enablement function that accelerates AI and automation rather than a data police unit. 4. Align performance incentives. Tie data stewardship and quality goals to the annual performance reviews of business department heads. Pro tip: give the program a brand name like Project Lighthouse to distance it from the failed attempt. A new name signals a new culture and prevents stakeholders from bringing old frustrations into your new meetings.
Scenario 12. Leadership wants governance embedded directly into DevOps and CI and CD pipelines. What are the technical steps?
Answer: to achieve seamless governance as code, I would integrate the following technical checkpoints into the pipeline. 1. Automated policy checks. Use Open Policy Agent OPA to define rules that are checked automatically during code commits. 2. PII detection scanning. Integrate tools that scan code for hard-coded secrets or unclassified sensitive data fields before deployment. 3. Enforce schema validation. Automatically block any deployment that attempts to push a schema change that violates downstream data contracts. 4. API-driven metadata harvesting. Ensure that every successful deployment automatically updates the data catalog metadata via API. Pro tip: use governance linter rules. Just like developers use linting for code quality, implement a linter that fails the build if a SQL file does not have metadata tags specifying the data owner and privacy level.
Scenario 13. Your organization has strong governance policies but zero enforcement. How do you fix this?
Answer: policies without enforcement are just suggestions. I would shift from manual enforcement to automated observability. By implementing a system that triggers an alert or blocks data access when a policy is violated, we move the burden from human auditors to the infrastructure itself. I would also publish a governance leaderboard to show which departments are complying, using social proof to drive adoption. Pro tip: implement access expiry. Instead of granting permanent data access, set a 90-day time to live for all permissions. Users have to justify their need for data every quarter, forcing compliance through the path of least resistance.
Scenario 14. Governance maturity differs heavily between departments. Finance is mature, marketing is chaotic. How do you handle this?
Answer: I would apply a tiered governance model. For finance, we maintain strict controls focusing on auditability and precision. For marketing, I would use a flexible discovery model that focuses on speed and data exploration. Instead of forcing marketing to adopt finance-level bureaucracy, I would focus on their specific pain point segmentation accuracy to show how governance helps them hit campaign targets. Pro tip: use control self-assessments. Let the marketing team grade their own maturity based on a simple checklist. When they see their own low score, they are much more likely to ask for help than if an auditor tells them they are failing.
Scenario 15. Executives want governance automation using AI agents. What capabilities are required?
Answer: leveraging AI agents transforms governance from a manual task to an autonomous function. Key required capabilities include 1. Autonomous classification, deploy agents that accurately tag sensitive data based on context and business use, not just basic regex. 2. Self-healing lineage, implement agents that analyze query logs to infer relationships and automatically repair broken lineage maps. 3. Proactive quality remediation, use agents that detect anomalies, identify root causes, and suggest SQL fixes directly to the data steward. 4. Natural language governance, provide a governance copilot that allows business users to find and understand data through plain English. Pro tip, do not start with full autonomy. Begin with AI-generated recommendations that require a human steward to hit approve. This builds a trust log for auditors before you flip the switch to full automation.
Scenario 16. A multinational enterprise wants one governance framework that works across 40 countries. How do you design it?
Answer: a global framework must be resilient enough for centralized standards, yet flexible enough for local legalities. I would design it as follows. 1. Core plus local framework. Define a global core for data security and architecture that applies to every region without exception. 2. Regional policy extensions. Allow countries to add layers for local laws, such as GDPR in Europe or LGPD in Brazil, without breaking core rules. 3. Standardize global entities. Create a global glossary for core entities like customer while allowing for localized attributes and translations. 4. Follow the sun stewardship. Establish regional stewardship hubs to handle localized issues in their own time zones and languages. Pro tip, use data sovereignty labels. Tag data with metadata like no exit Germany, so your cloud replication settings automatically respect local residency laws without manual intervention.
Scenario 17. The company wants governance integrated into digital transformation initiatives. What is your strategy?
Answer: I would position governance as the foundation of the new digital architecture. During a digital transformation, I would ensure that governance is baked into the data migration strategy from day one. This ensures we do not just move old mess to a new cloud, but instead use the transformation as a catalyst to clean, classify, and catalog our assets for the first time. Pro tip, make legacy retirement a core governance KPI. Digital transformations often fail because companies keep old systems running just in case. Use governance metrics to prove the old system is no longer trusted, helping IT shut it down.
Scenario 18. Your organization wants to benchmark governance maturity against competitors. What is your methodology?
Answer: benchmarking maturity is about measuring outcomes, not just activities. My methodology would include 1. DAMA DMBOK assessment. Use the standard industry framework to score the organization across 11 key data management areas. 2. Peer benchmark analysis. Engage with industry forums to understand the average maturity scores for our specific sector and size. 3. Outcome-based metrics. Compare time to market for data products and regulatory fine history against industry leaders. 4. Capability gap analysis. Identify specific areas where we are lagging and prioritize them based on their impact on the business roadmap. Pro tip, do not aim for level 5 maturity everywhere. It is too expensive. Aim for level 3 defined across the board, and only push for level 5 in domains that drive your competitive advantage, like AI.
Scenario 19. A company wants to transition from traditional governance to active metadata-driven governance. What is the roadmap?
Answer: moving to active metadata shifts governance from a reactive catalog to a proactive engine. I would follow this roadmap. 1. Modernize the catalog. Transition from manual entry catalogs to those that harvest metadata automatically via APIs and system logs. 2. Build a knowledge graph. Map technical metadata to business context to create a comprehensive network map of the data ecosystem. 3. Set event-driven workflows. Configure the system to trigger actions, such as revoking access, automatically when metadata changes occur. 4. Track usage metadata. Monitor how data is consumed to automatically prioritize governance for the most popular and critical datasets. Pro tip, use reverse ETL for metadata. Push data quality scores and ownership tags back into tools like Slack or BI headers. Active metadata only works if people see it in their daily workflow, not in a separate tool.
Scenario 20. Leadership asks whether governance should remain centralized or move to federated ownership. What is your recommendation?
Answer: for a modern 2026 scale enterprise, federated ownership is the only sustainable choice. A centralized team becomes a bottleneck that cannot keep up with data volume. However, the central team should evolve into a platform team that sets global standards and provides the tooling, while the actual ownership lies within the business units that know the data best. Pro tip: adopt a hub and spoke model where the hub owns tooling and security, and the spokes own definitions and quality. This ensures global consistency without stifling local business agility.
Category 1 Conclusion.
Mastering enterprise data governance strategy is about moving from a rigid, central police state to a flexible, federated enablement model. A successful strategy is measured by how quickly it supports AI product delivery and how seamlessly it integrates into developer workflows without adding friction. If your strategy is just a collection of PDF policies, it is already obsolete.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 1 to Category 2.
But even the most brilliant strategy is worthless if the data itself is broken. A strategy is the blueprint, but data quality is the foundation. If you build a federated architecture on top of toxic, inconsistent data, your AI models will simply generate wrong decisions at scale. Let's look at the real-world fires you will have to put out in Category 2.
Category 2 Data Quality Scenarios.
Data quality in the modern enterprise is no longer about running a weekly cleanup script. It is about data observability. Interviewers today want to know if you can detect anomalies in real time, solve root causes at the source, and automate remediation using AI. These scenarios test your ability to maintain trust in an environment where data moves at the speed of light.
Category 2 Data Quality Scenarios.
Here are the 25 critical data quality challenges we will be covering in this section. Scenario 21, Executive Dashboard Revenue Discrepancies across systems. Scenario 22, Duplicate customer addresses across CRM, ERP, and support platforms. Scenario 23, Sudden drop in data quality scores following a cloud migration. Scenario 24, Transitioning from weekly checks to real-time DQ monitoring. Scenario 25, Marketing campaign failure due to inaccurate segmentation data. Scenario 26, Lack of trust in operational data from product managers. Scenario 27, ML model failure caused by hidden training data bias. Scenario 28, Healthcare compliance risks from duplicate patient records. Scenario 29, Establishing standardized data quality dimensions. Scenario 30, Automating manual review of 200K records monthly. Scenario 31, unexpected null values in pipelines during peak hours. Scenario 32, inconsistent currency conversions across global systems. Scenario 33, managing high false positive rates in DQ rules. Scenario 34, outdated certified datasets leading to governance bypass. Scenario 35, quantifying the business cost of bad data for executives. Scenario 36, conflicting customer IDs ruining churn models. Scenario 37, automated root cause analysis for DQ failures. Scenario 38, inconsistent IoT sensor timestamp formats globally. Scenario 39, implementing AI-driven anomaly detection. Scenario 40, severe master data conflicts introduced by a merger. Scenario 41, managing orphan datasets in a massive data lake. Scenario 42, upstream team violations of DQ SLAs. Scenario 43, slow quality remediation causing governance rejection. Scenario 44, regulator inquiries into financial reporting integrity. Scenario 45, real-time fraud detection failure via delayed sync. We will now dive into the deep dive answers for each of these scenarios.
Scenario 21. A dashboard used by executives shows different revenue numbers across systems. How do you resolve this discrepancy?
Answer: revenue discrepancies usually stem from inconsistent transformation logic or timing differences between the CRM and the ERP. To resolve this, I would follow these 4 steps. 1. Trace the lineage. Map the data flow from the source CRM, for example, Salesforce, and ERP, for example, SAP, to the reporting layer to identify where the calculations diverge. 2. Standardize recognition logic. Audit the SQL transformations to ensure both systems treat net revenue identically, specifically how they handle discounts, tax, and returns. 3. Audit sync latency. Check if the discrepancy is simply a timing issue, where the CRM reflects real-time sales while the ERP waits for nightly batch processing. 4. Implement a reconciliation layer. Build an automated check that flags any variance exceeding 0.5% between systems before the data hits the executive dashboard. Pro tip: look for deleted records in the source system. Often, a sale is canceled in the CRM, but the delete flag does not propagate to the data warehouse, causing the warehouse to report higher revenue than the source.
Scenario 22. Customer addresses are duplicated across CRM, ERP, and support platforms, making it impossible to get a single view of customer. What is your plan?
Answer: address duplication is an identity resolution problem. I would implement a multi-phased master data management (MDM) strategy. 1. Standardize formats. Use a global address verification API like Locate or Melissa to convert all strings into a standardized format, for example, st dot to street. 2. Fuzzy matching logic. Deploy Levenshtein distance or Jarrow-Winkler algorithms to identify high probability matches that traditional exact match queries miss. 3. Establish survivorship rules. Define which system is the source of truth, for example, the ERP for billing addresses and the CRM for shipping addresses. 4. Automated merge purge. Execute a controlled merge of duplicate records into a golden record, while maintaining a crosswalk table to track original IDs. Pro tip: never delete the loser records during a merge. Move them to a historical archive and store their original IDs in the golden record so you can still track historical transactions if an analyst needs to audit the old data.
Scenario 23. Data quality scores suddenly drop after a major cloud migration. The data looks correct, but the automated checks are failing. How do you investigate?
Answer: I would start by auditing the data physics of the new environment. Often, migration tools subtly change data types, for instance, trailing spaces in a fixed length string or precision loss in decimal fields, which causes quality rules to fail even if the data appears identical. I would compare a row-by-row hash of the source versus the destination. If the hashes match, the issue lies in the DQ rules themselves. They may not be optimized for the new engine syntax or character encoding like UTF-8 versus ASCII. Pro tip: check your null handling in the new cloud database. Some cloud warehouses treat empty strings and null differently than on-premise systems, which can break every completeness rule in your library overnight.
Scenario 24. Your company wants real-time data quality monitoring instead of weekly checks to support high-frequency trading or logistics. How do you architect this?
Answer: moving from batch to real-time DQ requires shifting the checks upstream into the stream processing layer. I would design the architecture as follows. 1. In stream validation, use Kafka streams or Flink to apply schema validation and threshold checks on data packets while they are still in transit. 2. Dead letter queues. Configure the pipeline to automatically route any record failing a critical DQ check into a quarantine queue for immediate investigation. 3. Micro-batch observability. Implement a dashboard that visualizes data drift and volumetric anomalies in 1-minute intervals rather than 24-hour summaries. 4. API-driven alerts. Integrate the DQ engine with PagerDuty or Slack to notify data engineers within seconds of a pipeline violation. Pro tip: do not run complex SQL-based DQ checks on a live stream, as it will tank your performance. Use lightweight metadata checks like byte size or record count on the stream, and save the deep logic for the first landing table.
Scenario 25. Marketing campaigns are failing because customer segmentation data is inaccurate. Marketing blames governance. How do you address the root cause?
Answer: I would perform a segment integrity audit to show that the issue is not the governance policy, but the data decay at the point of entry. In many cases, marketing teams use third-party lists or web forms with no validation, leading to garbage in at the CRM level. I would propose implementing mandatory validation at the source, such as email verification and drop-down only fields for job titles, to ensure the data is accurate before it ever reaches the segmentation engine. Pro tip: calculate the cost of a bounced email. Showing the marketing director exactly how many dollars were wasted on failed sends due to bad data will turn them from a governance critic into your biggest advocate for better DQ controls.
Scenario 26. Product managers complain that analytics teams do not trust operational data, leading to shadow analytics where teams build their own rogue reports. How do you rebuild trust?
Answer: trust is rebuilt through transparency, not just cleaner data. I would launch a data certification program. When a dataset is audited and passes our DQ thresholds, it gets a certified badge in the data catalog. I would also publish the DQ health scorecard directly on the dashboard. If an analyst can see exactly when the data was last refreshed and its current completeness score, they stop guessing and start relying on the official source again. Pro tip: build a data trust Slack channel. Allow analysts to report bugs in the data just like software bugs. When you acknowledge and fix a data bug in 24 hours, you prove that governance is an active service, not a static department.
Scenario 27. A machine learning model failed because training data contained hidden bias, leading to discriminatory outputs. How do you implement DQ to prevent this?
Answer: bias in ML is often a representativeness DQ issue. To prevent this, I would implement these fairness DQ dimensions. 1. Demographic parity audit. Use automated checks to ensure the training dataset matches the real-world distribution of the target population across protected attributes. 2. Feature correlation analysis. Identify if proxy variables like zip code are acting as a stand-in for protected classes like race or income. 3. Class imbalance detection. Set alerts for underrepresented samples. If the model is training on 95% of data from one group, it will naturally fail the other 5%. 4. Lineage tracking for labels. Audit the human labeling process to ensure the people tagging the training data are not introducing their own subjective biases into the set. Pro tip: use synthetic minority over sampling SMOT to rebalance your datasets. Governance should recommend technical solutions to bias, not just point out that the data is imbalanced.
Scenario 28. Duplicate patient records are causing healthcare compliance risks and potential medical errors. How do you handle this high-stakes DQ issue?
Answer: in healthcare, DQ is a matter of life and death. I would implement an EHR integrity framework focused on patient safety. 1. Deterministic and probabilistic matching. Use deterministic matching for SSNs and government IDs, and probabilistic matching for names and birth dates. 2. Real-time duplicate warning. Implement a trigger in the patient registration system that flags a potential duplicate before the record is saved, forcing a manual review. 3. Clinical data reconciliation. If two records are merged, Ensure that clinical notes, allergy lists, and medication histories are combined safely by a licensed clinician. 4. Audit trail for merges. Maintain a strict ledger of every unmerge and merge action to comply with healthcare audits and HIPAA regulations. Pro tip: focus on mother's maiden name and birth city as tiebreaker fields. These are much more stable over time than addresses or phone numbers, which change frequently and lead to false duplicates.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 29. Your organization lacks standard data quality dimensions. How do you define and implement them across the enterprise?
Answer: to create a common language for quality, I would implement the 6 standard DAMA dimensions, tailored to our business context. 1. Completeness: are mandatory fields like email or transaction amount populated, or are they unexpectedly null? 2. Uniqueness: do we have duplicate records for the same real-world entity, such as 2 IDs for one employee? 3. Consistency: does the customer status in the CRM match the customer status in the billing platform? 4. Validity: does the data follow the required format, such as a 5-digit zip code or a valid ISO currency code? 5. Accuracy: does the data reflect the real-world truth? For example, is the inventory count in the database what's actually on the shelf? 6. Timeliness: is the data available when it is needed? Is the daily sales report actually updated by 8 a.m. every morning? Pro tip: do not try to measure all 6 dimensions for every table. Focus on critical data elements, CDEs. A missing middle name is a completeness issue, but it should not stop a multi-million-dollar report.
Scenario 30. A data steward is overwhelmed, manually reviewing 200K records every month for errors. How do you automate this using modern AI?
Answer: I would replace manual review with an active learning model. I would train a machine learning model using the steward's past 6 months of approved versus rejected records. The model would then categorize incoming data into 3 buckets: auto-approved high confidence, auto-rejected definite errors, and steward review ambiguous. This usually reduces the manual workload by 80% to 90%, allowing the steward to focus only on the truly complex cases. Pro tip: do not just automate the fix, automate the feedback loop. When the steward manually fixes an ambiguous record, that decision should automatically retrain the model so it gets smarter for the next month.
Scenario 31. Data pipelines generate null values unexpectedly during peak hours, causing reporting outages. How do you find the root cause?
Answer: peak hour nulls are almost always an infrastructure or timeout issue rather than a data issue. I would investigate using this checklist: T.1. API timeout audit. check if the upstream source system is hitting rate limits or timing out under high load, causing the ETL tool to receive empty responses. 2. Memory and compute pressure. Audit the Spark or Snowflake warehouse logs to see if the pipeline is being killed due to out-of-memory errors during the peak shuffle. 3. Upstream lock contention. Check if the source database is being locked by heavy read and write operations during peak hours, preventing the ETL from fetching data. 4. Deadlock analysis. Look for race conditions where two parallel pipelines are trying to update the same target table simultaneously, leading to null overwrites. Pro tip: implement circuit breakers. If a pipeline starts producing more than 5% null values, the system should automatically kill the job and alert the engineer, rather than letting bad data reach the final dashboard.
Scenario 32. You discover inconsistent currency conversions across global systems. Some use the end-of-day rate, while others use the spot rate. How do you standardize this?
Answer: I would implement a centralized enterprise exchange rate service. Instead of every system doing its own math, I would build a master reference table that pulls the official daily closing rate from a trusted source like Bloomberg or Reuters. All downstream ETL processes must join with this master table to perform their conversions. This ensures that a $1 million sale in London is reported exactly the same in New York and Tokyo, regardless of which local system captured it. Pro tip: always store the original amount and original currency alongside the converted functional currency. If exchange rates are audited or changed later, you need the original values to recalculate without losing data integrity.
Scenario 33. Data quality rules are causing too many false positives, leading to alert fatigue for the data engineering team. How do you tune them?
Answer: alert fatigue happens when DQ rules are too rigid. I would implement dynamic thresholds to reduce the noise. 1. Historical baselines instead of a hard rule. For example, fail if null greater than 0. Use a moving average. For example, fail only if nulls are 3 standard deviations above the 30-day average. 2. Segment-specific rules. Do not apply the same DQ rules to testing accounts as you do to premium accounts. Allow higher error rates for low-priority data. 3. Classification of alerts. Separate alerts into warnings for documentation/review and critical, which stop the pipeline. 4. Root cause grouping. Use AI to group 50 individual column failures into a single upstream system outage alert to avoid redundant notifications. Pro tip: implement confidence scores. Instead of a pass or fail, give the data a score from 0 to 100. Let the downstream consumer decide their own risk tolerance. A marketing team might accept a score of 70, but finance needs a 98.
Scenario 34. Data analysts are bypassing governance controls and using shadow datasets because the official certified datasets are outdated and slow. How do you fix this?
Answer: this is a classic governance versus agility conflict. Analysts bypass controls because the cost of compliance is higher than the risk of being wrong. I would implement an active certification model where datasets have an automated time to live TTL. Instead of a one-time badge, certification remains valid only if the data quality scores stay above a certain threshold and the metadata is refreshed monthly. By making the official path the fastest path through better performance and pre-joined tables, you eliminate the incentive for shadow IT. Pro tip: monitor your catalog search to query ratio. If people are finding data in your catalog, but then querying different, undocumented tables in your warehouse, it's a red flag that your certified assets are no longer meeting business needs.
Scenario 35. An executive asks how you would quantify the actual business cost of bad data. What is your calculation framework?
Answer: to move the board to action, I translate data errors into financial impact using these 4 cost pillars. 1. Operational labor waste. Calculate the hours analysts spend manually cleaning data, multiplied by their hourly loaded salary. 2. Cloud compute surcharge. Identify the cost of running failed ETL jobs and processing redundant or junk records in the data warehouse. 3. Opportunity cost of attrition. Estimate revenue lost from failed marketing campaigns or customer churn caused by incorrect billing or duplicate communications. 4. Regulatory and legal risk. Quantify potential fines from data privacy violations like GDPR that stem directly from poor data classification, or lack of deletion enforcement. Pro tip: use the 1 to 10 to 100 rule for your presentation. It costs $1 to prevent an error at entry, $10 to correct it later, and $100 in lost revenue if the bad data reaches the customer.
Scenario 36. Customer churn models are highly inaccurate because different source systems use conflicting customer IDs for the same individual. How do you resolve this for the data science team?
Answer: the churn model is failing because the identity fragmentation creates gaps in the customer journey. I would implement a global identity crosswalk table. Instead of forcing all systems to change their IDs, we map every local ID, for example, Web ID, CRM ID, Store ID, to a single enterprise global ID. By providing the data science team with a pre-joined identity graph, they can see the full sequence of events from a support ticket to a missed payment regardless of which system captured the event. Pro tip: look for leaking identities. Often, a customer browses while logged out Web ID and then logs in User ID. Using probabilistic stitching based on IP address and browser fingerprint can help connect these two identities before they actually churn.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 37. Your organization wants to move away from manual troubleshooting and implement automated root cause analysis (RCA) for data quality failures. How do you design this?
Answer: automated RCA requires a shift from passive monitoring to active metadata analysis. I would design the workflow as follows. 1. Lineage linked alerts. When a DQ check fails on a dashboard, the system automatically traverses the lineage graph to find the first upstream point where the error appeared. 2. Schema drift detection. The AI agent compares the current table schema against the historical baseline to see if an unannounced column change caused the breakage. 3. Volume anomaly correlation. Correlate the failure with data volumetric changes, for example. A 50% drop in records from the source API usually points to a system outage rather than a data error. 4. Downstream impact analysis. Automatically generate a list of all impacted reports and users, notifying them before they make decisions based on the broken data. Pro tip: integrate your DQ tool with the engineering team's deployment logs. Most data quality root causes are actually just software engineers deploying a code change without realizing it impacts the data warehouse.
Scenario 38. IoT sensor data from factories in 10 different countries contains inconsistent timestamp formats, making global performance comparisons impossible. How do you standardize this?
Answer: inconsistent time series data destroys the integrity of global analytics. I would enforce a standardized landing process. 1. Enforce ISO 8601. Require all IoT edge gateways to transmit data using the ISO 8601 standard YMMDDTHH:MM:SSZ. 2. Universal UTC storage, regardless of the factory's local time. All data must be converted and stored in UTC at the landing zone. 3. Metadata enrichment. Store the local offset as a separate metadata column so factory managers can still view reports in their local time when needed. 4. Granularity normalization. Use a resampling logic in the ETL to ensure a sensor sending data every second and one sending every minute are aggregated into a consistent hourly view. Pro tip: watch out for leap seconds and daylight savings shifts in legacy PLC controllers. Some older IoT devices do not handle these shifts automatically, leading to a missing hour of data twice a year.
Scenario 39. Your company wants to implement AI-driven anomaly detection for data quality because static rules are too hard to maintain. What is your implementation strategy?
Answer: static rules like value must be greater than 0 are brittle. My strategy is to move toward distribution-based observability. We use machine learning to profile the last 90 days of data and establish a normal distribution for every column. If a new batch of data arrives where the mean, standard deviation, or null count is more than 3 sigma away from the historical norm, the system flags it as an anomaly. This allows the governance team to catch unknown unknowns that a human would never think to write a rule for. Pro tip: start with uniqueness and volume as your first AI-driven metrics. They are mathematically simple to baseline and provide the highest signal-to-noise ratio when catching major pipeline failures.
Scenario 40. A major merger has introduced severe master data conflicts, with two companies having different product codes and customer lists. How do you resolve this?
Answer: merger-driven data conflict is a high-risk event. I would follow this master data harmonization roadmap. 1. Discovery profiling. Run a cross-system profiling exercise to identify the overlap percentage between the two customer and product databases. 2. Define survivorship logic. Decide which company's attributes win in a conflict, usually based on which system is newer or has higher field-level completeness. 3. Map to a reference taxonomy. Instead of moving one company into the other system, map both to a neutral target state taxonomy to ensure future scalability. 4. Deploy a crosswalk API until the systems are fully merged. Provide a translation layer so a user can search a code from company A and find the equivalent in company B. Pro tip: do not try to merge everything at once. Focus on customer and product first. These are the two entities that impact revenue reporting and financial statements immediately after a merger.
Scenario 41. A data lake has become a data swamp containing thousands of orphaned and undocumented datasets. How do you clean this up without breaking existing reports?
Answer: I would implement a data lifecycle garbage collection policy. First, I use usage metadata to identify cold data, datasets that haven't been queried in over 90 days. Instead of deleting them, I move them to an archive tier and add a deprecation warning tag in the catalog. If no one complains for another 30 days, I move the data to cold storage. This soft delete approach allows us to clean the lake while providing a safety net if a legacy quarterly report suddenly breaks. Pro tip: use Lineage to owner mapping. Often, datasets are orphaned because the employee who created them left the company. Automatically reassigning orphan data to the current department head forces the business to decide if the data is worth the storage cost.
Scenario 42. Upstream engineering teams are constantly violating data quality SLAs, causing downstream analytics to fail. How do you enforce accountability?
Answer: you cannot enforce accountability through emails. You must enforce it through data contracts. I would implement a technical agreement between the producer's engineers and consumers' analysts. If the engineers want to change a schema, or if their data falls below the agreed quality threshold, the data contract fails, and the build is blocked in their own environment. By moving the pain of bad data back to the person who created it, you align the incentives for high-quality data at the source. Pro tip: include data quality in the engineering team's definition of done. If the code is working but the data output is junk, the feature is not finished and should not be deployed to production.
Scenario 43. Business users are rejecting the governance program because quality remediation takes too long. How do you accelerate the process?
Answer: slow remediation is usually caused by manual handoffs. I would optimize the workflow using these three tactics. 1. Automated ticket routing. Integrate the DQ tool directly with Jira. If a critical DQ rule fails, a ticket is automatically created and assigned to the specific data steward responsible for that domain. 2. Self-service remediation. Provide a data correction UI for business users, allowing them to fix simple errors like misspelled names directly in the master database without writing SQL. 3. AI-suggested fixes. Use LLMs to analyze the error and suggest the most likely correction to the steward, turning investigation into a one-click approval process. Pro tip: implement a remediation SLA. Track how long it takes for a data error to be closed. Publishing a mean time to repair MTTR for data issues makes the governance process as visible and professional as IT support.
Scenario 44. A regulator questions the integrity of your financial reporting data. How do you prove that the data hasn't been tampered with?
Answer: integrity proof requires an immutable audit trail. I would provide the regulator with the following evidence. 1. End-to-end lineage, a visual map showing every transformation step from the raw source to the final financial statement. 2. System audit logs, proof of who accessed what and when, ensuring that no unauthorized manual edits were made to the production data. 3. Data immutability proof, demonstration of write-once-read many-worm storage or blockchain-style hashing that proves the data hasn't changed since it was landed. 4. Reconciliation reports, automated checks that prove the sum of the source transactions matches the sum of the reported figures down to the penny. Pro tip: always keep historical snapshots of your data. If a regulator asks about a report from 3 years ago, you need to be able to recreate that exact report using the data as it existed at that time, not as it exists today.
Scenario 45. Real-time fraud detection systems are failing because the data synchronization between the transactional database and the AI model is delayed. How do you resolve this?
Answer: this is a data freshness or latency issue. If the fraud model is looking at data that is even 5 minutes old, the attacker has already moved on. I would move away from batch syncing and implement change data capture CDC. Tools like Debezium can stream every database change insert/update/delete into a Kafka topic in milliseconds. The fraud detection AI then consumes this live stream directly, ensuring it is always making decisions on the current state of the account, not a historical snapshot. Pro tip: monitor event-to-action latency. Track the time from when a transaction happens to when the fraud model makes a decision. If this exceeds your SLA for safety, the system should automatically fail safe and block high-value transactions until the sync catches up.
Category 2 Conclusion.
Mastering data quality is about shifting from reactive cleanup to proactive observability. In the modern enterprise, quality is not a one-time project. It is a continuous stream of truths. When your data is accurate, timely, and consistent, your AI models and business leaders can finally stop second-guessing their insights and start making high-stakes decisions with confidence.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 2 to Category 3.
But having high-quality data is only half the battle. Clean data is useless if no one can find it, understand its context, or trace where it came from. This is where metadata management comes in. If data quality is the foundation of the house, metadata is the blueprint and the GPS that tells you exactly what is inside. Let's explore Category 3.
Category 3. Metadata Management Scenarios.
Metadata is the data about data, and in an AI-driven world, it is the most valuable asset you own. Modern metadata management is no longer a static spreadsheet. It is an active, automated ecosystem of catalogs, business glossaries, and lineage maps. These scenarios will test your ability to organize massive amounts of information into a searchable, trusted library.
Category 3. Metadata Management Scenarios.
Here are the 20 critical metadata management challenges we will be covering in this section. Scenario 46, launching a centralized data catalog from scratch. Scenario 47, reducing time to data for analysts searching for trusted sets. Scenario 48, resolving duplicate and conflicting terms in business glossaries. Scenario 49, connecting technical metadata with business-friendly context. Scenario 50, implementing automated metadata harvesting across multi-cloud platforms. Scenario 51, fixing incomplete data lineage for critical regulatory reporting. Scenario 52, managing inaccuracies in AI-generated metadata classifications. Scenario 53, restoring trust in metadata when ownership info is outdated. Scenario 54, integrating active metadata into automated governance workflows. Scenario 55, identifying and tagging sensitive datasets missing classification. Scenario 56, overcoming business user resistance to maintaining glossary definitions. Scenario 57, implementing semantic layer governance for self-service BI tools. Scenario 58, resolving metadata sync failures between Snowflake and governance tools. Scenario 59, moving toward metadata-driven, automated access control. Scenario 60, producing end-to-end lineage for regulators within 24 hours. Scenario 61, training AI copilots exclusively on certified enterprise metadata. Scenario 62, detecting and documenting shadow datasets used by consumers. Scenario 63, building an enterprise knowledge graph for advanced metadata discovery. Scenario 64, identifying and labeling authoritative sources of truth. Scenario 65, automated impact analysis to prevent schema change breakages. We will now dive into the expert-level answers for these metadata management scenarios.
Scenario 46. Your company has no centralized data catalog, and tribal knowledge is the only way to find data. How do you launch a catalog from scratch?
Answer: launching a catalog is a marathon, not a sprint. I would prioritize a value-first rollout using these 4 phases. 1. Inventory critical data elements CDEs. Start by cataloging only the datasets that drive the top 3 business reports to show immediate value. 2. Automated metadata harvesting. Deploy technical scanners to pull schemas, table names, and query logs from your primary data warehouse, for example, Snowflake or BigQuery. 3. Crowdsource business context. Empower data stewards to add descriptions and business terms to the most frequently queried tables FIRS T. 4. Integrate with Slack/Teams. Make the catalog searchable within the communication tools analysts already use to drive daily adoption. Pro tip: do not try to catalog everything at once. A data swamp with 10,000 undocumented tables is worse than a catalog with 50 perfectly documented gold tables. Aim for quality over quantity in the first 90 days.
Scenario 47. Analysts complain they spend hours searching for trusted datasets, often giving up and creating their own versions. How do you reduce this time to data?
Answer: the issue here is not just searchability. It is True's T. I would implement popularity and trust signals within the catalog. Much like an e-commerce site, the catalog should show which datasets are most frequently used, who the top users are, and whether a dataset has been certified by a steward. By providing a Google-like search experience that prioritizes certified, high-usage assets, we reduce discovery time from hours to minutes. Pro tip: implement data previews and sample queries. Analysts often waste time joining a table only to realize it is the wrong one. Letting them see a 10-row sample and a top 5 SQL snippets for that table directly in the catalog speeds up their decision-making significantly.
Scenario 48. Business glossaries contain duplicate or conflicting business terms. For example, customer means something different to sales versus finance. How do you resolve this?
Answer: glossary conflicts are a symptom of siloed operations. I would resolve these through a multi-tenant glossary architecture. 1. Establish a global namespace. Define a core enterprise glossary for terms that everyone agrees on, for example, tax ID. 2. Allow functional glossaries. Create sub-glossaries for specific departments, allowing customer finance and customer marketing to exist as distinct terms. 3. Map to a semantic layer. Use metadata to link these different terms to the specific SQL columns in the database where they are calculated. 4. Formalize the approval workflow. Require a cross-functional sign-off before any term is promoted from a departmental level to the enterprise level. Pro tip: use synonyms in your catalog search. If an analyst searches for client but your official term is customer, the metadata engine should be smart enough to return the correct results anyway.
Scenario 49. Technical metadata SQL types and business metadata definitions are disconnected. Analysts see the column AMT_01, but do not know it means gross revenue. How do you bridge this gap?
Answer: this requires logical to physical mapping. I would use a metadata platform that allows for bulk tagging and semantic inference. By analyzing the data distribution in AMT_01 and comparing it to historical patterns, an AI agent can suggest that this column is likely gross revenue. Once confirmed by a steward, the business term is permanently mapped to the technical column across all Lineage maps, ensuring that any analyst who searches for revenue finds the correct technical field. Pro tip: use alias views in your data warehouse. Instead of forcing analysts to remember AMT_01, create a governed view layer where the column is renamed to gross_revenue. This moves the business metadata directly into the query environment.
Scenario 50. The organization wants automatic metadata harvesting across multiple cloud platforms, AWS, Azure, and SaaS. How do you architect this without manual entry?
Answer: automated harvesting requires an API-first metadata strategy to avoid the trap of static documentation. I would design the architecture as follows. 1. Deploy cross-cloud scanners. Use a catalog that provides native connectors for object storage S3/blob, databases Snowflake or Redshift, and SaaS Salesforce or Workday. 2. Scheduled metadata crawls. Set up automated triggers that scan for schema changes, new tables, and updated permissions every 24 hours. 3. Query log parsing. Implement active lineage by parsing SQL logs to automatically detect how data flows between different cloud providers without human intervention. 4. Unified metadata lake. Centralize all harvested metadata into a single searchable knowledge graph regardless of where the physical data resides. Pro tip: be careful with scanning costs. Some cloud platforms charge per metadata. Risk configure your scanners to do incremental crawls, only looking for what changed since the last scan to keep your cloud bill under control.
Scenario 51. Data lineage is incomplete for critical regulatory reports. There are black boxes where data moves through undocumented scripts. How do you fix this?
Answer: incomplete lineage is a massive audit risk. I would implement log-based reconstruction. Most black boxes are actually stored procedures or Python scripts. By feeding these scripts into a lineage parser that supports multi-dialect SQL analysis, the tool can deconstruct the code and visualize the missing hops. For legacy systems where code cannot be parsed, I would implement system-level fingerprinting to track data movement based on source/target timestamps and volume correlations. Pro tip: focus on impact analysis. When a source system changes, the most important part of Lineage is not where the data came from, but which regulatory reports will break tomorrow. Prioritize your Lineage efforts around the last mile of reporting.
Scenario 52. AI-generated metadata classifications, for example, automatically tagging confidential data are inaccurate, leading to false positives and security gaps. How do you improve this?
Answer: AI tagging is a starting point, not the final word. I would implement a human-in-the-loop verification framework. 1. Probability thresholds. Configure the AI to only apply tags automatically if the confidence score is above 95%. Anything lower is flagged as a suggestion for human review. 2. Feedback reinforcement. Create a UI where stewards can thumbs up or thumbs down an AI tag, feeding that data back into the model to improve future accuracy. 3. Contextual pattern matching. Move beyond simple rejects like checking for 16 digits and use NLP to analyze column headers and surrounding metadata to understand the intent of the data. 4. Sampling validation. Periodically run a manual audit on AI-approved tags to ensure the model is not drifting or missing new types of sensitive data. Pro tip: use negative sampling. Train your AI on what sensitive data looks like as well as what it does not look like. For example, distinguishing a customer ID from a random product SKU to drastically reduce false positives.
Scenario 53. Teams do not trust the metadata catalog because ownership information is outdated. The listed data owner left the company 2 years ago. How do you keep ownership metadata evergreen?
Answer: ownership cannot be a manual attribute. It must be an active one. I would integrate the metadata catalog with the HR system like Workday and the Active Directory. When an employee leaves or changes departments, the system should automatically flag their owned assets as orphaned. An automated workflow then notifies the employee's manager to reassign the assets. I would also implement usage-based ownership dash. If someone is the primary contributor to a table in GitHub or SQL logs, the catalog should suggest them as the technical owner. Pro tip: implement a stewardship heat map. Show which departments are actually maintaining their metadata versus those that are letting it rot. Social pressure and executive visibility are the best ways to keep metadata from becoming outdated.
Scenario 54. Your company wants active metadata integrated into governance workflows. How do you move from a passive catalog to an action-oriented one?
Answer: active metadata is about using metadata to trigger business processes. I would implement these 3 automation use cases. 1. Auto quarantine. If a metadata scan detects unmasked PII in a public folder, the system should automatically move that dataset to a restricted zone and alert security. 2. Adaptive access control. Instead of manual roles, the system grants access based on the classification tag. If a table is tagged internal, access is granted. If it is changed to restricted, access is revoked. 3. Schema change alerts. If a metadata scan detects a schema change that breaks a downstream certified report, it automatically creates a high-priority ticket for the pipeline engineer. 4. Cost-based deprecation. If metadata shows a dataset hasn't been queried in 120 days, the system triggers a soft delete workflow to move it to cold storage. Pro tip: start with alerting before moving to blocking. Let the active metadata notify humans of an issue for the first few months. Once the logic is proven, you can flip the switch to autonomous enforcement.
Scenario 55. Thousands of sensitive datasets are missing classification tags, creating a massive compliance gap. How do you handle this at scale?
Answer: you cannot tag 1,000 tables manually. I would use lineage propagation, also known as tag inheritance. If I tag a single raw column as PII at the point of ingestion, the metadata platform should automatically propagate that tag downstream to every view, join table, and dashboard that consumes it. This tag once, govern everywhere approach ensures that your security controls follow the data as it moves through the enterprise architecture. Pro tip: use cluster-based tagging. Group similar tables, for example, all 50 tables in the marketing schema, and apply a default classification. It is better to overclassify and then refine than to leave thousands of tables with no classification at all.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 56. Business users and domain experts refuse to maintain glossary definitions, viewing it as a boring IT task that adds to their workload. How do you drive adoption?
Answer: resistance usually occurs because users do not see the immediate value. I would pivot from documentation to self-service enablement. I would demonstrate how a well-maintained glossary reduces the hundreds of repetitive "what does this column mean?" emails they receive every month. By implementing in-context metadata where definitions pop up directly inside their BI tools like Power BI or Tableau. When they hover over a field, we make the glossary a tool they rely on daily, rather than a separate database they have to maintain. Pro tip: use gamification and leaderboards. Publicly track which departments have the highest percentage of approved definitions. Executive visibility into documentation maturity often turns metadata maintenance from an ignored task into a competitive priority for business leads.
Scenario 57. The company wants to implement semantic layer governance for self-service BI to ensure everyone calculates gross margin the same way. How do you govern this?
Answer: governing the semantic layer prevents metric anarchy. I would implement a 3-tiered metric governance strategy. 1. Centralize logic in code. Use a headless BI or metric store like dbt semantic layer or cube to define calculations in a single YAML file rather than inside individual reports. 2. Implement metric certification. Only metrics that have been peer-reviewed and signed off by finance receive a gold badge in the BI environment. 3. Restrict logic overrides. Disable the ability for casual users to create custom calculated fields in the BI tool for enterprise-level KPIs, forcing them to use the governed metrics. 4. Version control for metrics. Treat metric changes like software changes, requiring a pull request PR and impact analysis before a new formula is deployed. Pro tip: start a metric dictionary. Beyond just the formula, document the when to use and when not to use context for complex KPIs to prevent analysts from misinterpreting the data in their presentations.
Scenario 58. Metadata synchronization is failing between your Snowflake warehouse and your governance tool, for example, Colibra. The catalog is missing new tables created in the last week. How do you troubleshoot this?
Answer: this is likely a credential or driver failure. I would first check the harvesting service account in Snowflake to ensure it hasn't been locked or had its RSA keys rotated. Next, I would audit the information schema query logs to see if the catalog's crawler is hitting a request timeout or rate limit due to a massive increase in table volume. If the connection is fine, I would check the inclusion/exclusion filters in the governance tool to ensure someone didn't accidentally exclude the new schemas from the sync schedule. Pro tip: check for schema drift. If a developer renamed a schema or moved tables to a new database without updating the crawler's configuration, the sync will silently fail to pick up the new assets even if the connection is successful.
Scenario 59. The organization wants to move toward metadata-driven access control (MDAC). How do you architect a system where metadata tags dictate security permissions?
Answer: MDAC removes the manual burden of role-based security. I would design the architecture using these 4 pillars. 1. Automated classification. Use an AI scanner to identify sensitive columns SSN, salary, and apply a uniform restricted metadata tag at the object level. 2. Policy orchestration. Use a tool like Immuta or Privacera to create a global policy. If column.tag is equal to PII, then redact for all users except HR role. 3. Tag inheritance. Ensure that if a raw table is tagged, all downstream views and CTAS tables automatically inherit those security tags via the lineage graph. 4. Dynamic masking. Apply masking, for example, showing only the last 4 digits in real time based on the user's attributes and the data's metadata tag, rather than creating separate masked tables. Pro tip: beware of tag latency. There is often a delay between a new table being created and the AI scanner tagging it. Implement a default deny policy where any untagged data is treated as restricted until the scanner verifies it.
Scenario 60. A regulator demands end-to-end lineage for a specific financial figure within 24 hours. Your automated lineage is broken for that path. How do you respond?
Answer: this is a war room scenario. Since automated lineage is down, I would initiate manual reconstruction by pulling the SQL code from the query history and the Git repository for the last 30 days. I would pair a data engineer with a lead analyst to trace the hops from the raw source to the report, documenting each transformation in a temporary visual map. I would provide the regulator with this verified manual map while being transparent about the technical outage, proving that we have the human expertise to verify the data's integrity even when the automation fails. Pro tip: always maintain a golden path lineage. Identify the 10 most critical regulatory reports and export their lineage as a static PDF every month. If the system goes down during an audit, you have a verified snapshot to show the regulator immediately.
Scenario 61. Your organization is launching internal AI copilots and wants them trained or grounded only on certified metadata. How do you enforce this?
Answer: to prevent AI hallucinations, you must build a metadata guardrail for your LLMs. I would implement the following. 1. Metadata filtering for RAG. When the AI performs a retrieval step, filter the search query to only include assets with the certified or production metadata tag. 2. Exclude shadow schemas. Explicitly block the AI from indexing sandbox, dev, or personal schemas where data is often undocumented and unverified. 3. Verified business context. Only feed the AI definitions that have been approved in the business glossary, ensuring the chatbot uses the official enterprise terminology. 4. Prompt context injection. Automatically inject the trust score of a dataset into the AI's prompt, instructing it to warn the user if it is answering based on a low-confidence data source. Pro tip: implement a hallucination feedback loop. If a user reports that the AI provided a wrong definition, use lineage metadata to find the source of truth and update the catalog immediately to prevent the error from repeating.
Scenario 62. Data consumers are using undocumented shadow datasets they found in S3 buckets rather than the official catalog. How do you bring these into the light?
Answer: consumers use shadow data because the official data is either too hard to find or missing the attributes they need. I would use storage profiling to find these undocumented buckets and analyze the access logs to see who is querying them. Instead of shutting them down immediately, I would interview the shadow owners to understand their use case. I would then onboard these datasets into the official catalog, adding the missing metadata and certification, effectively turning shadow IT into distributed governance. Pro tip: Monitor your catalog mismetrics. If people are searching for terms in your catalog and getting 0 results, but then querying S3 directly, your metadata catalog is missing the data the business actually needs to function.
Scenario 63. Your enterprise wants to build a knowledge graph for metadata to show the relationship between people, data, and processes. How do you model this?
Answer: a knowledge graph moves beyond flat lists to show the contextual web of your data. I would model the graph using these relationship types. 1. Data to system lineage. Show that table in Snowflake is derived from APIX in Salesforce. 2. Data to people ownership. Link table to its business steward and its most frequent power users. 3. Data to process usage. Connect datasets to the specific business processes they support, such as monthly financial close or customer onboarding. 4. Term to object semantic. Link business terms in the glossary to every physical column, report, and AI prompt where that term is utilized. Pro tip: use a graph database like Neo4j or Amazon Neptune for this. Standard SQL databases struggle with the deep joins, required to show how a person in one department is related to a dataset used by a system in another department.
Scenario 64. Teams are struggling to identify authoritative data sources, ADS, often using 3 different versions of total sales. How do you standardize the ADS metadata?
Answer: I would implement a gold, silver, bronze certification standard. Only one system can be the gold source for a specific data subject, for example, the ERP for financials. In the metadata catalog, I would use a verified ADS flag that appears at the top of search results. I would also implement deprecation metadata for the other 2 versions, clearly stating, this dataset is for departmental use only for enterprise reporting. Use the gold source found here. Pro tip: link your ADS status to your system of record SOR. If a system is the original point of entry for a data element, it should default as the ADS. If data is modified or transformed downstream, it loses its ADS status unless it goes through a formal enterprise certification.
Scenario 65. The company wants to implement automated impact analysis to prevent downstream reports from breaking every time a developer changes a database schema. How do you design this?
Answer: automated impact analysis is a critical part of a modern data DevOps pipeline. I would design the workflow as follows. 1. CI and CD lineage trigger. When a developer creates a pull request to change a column name, an automated script queries the metadata API to find all downstream dependencies. 2. Automated stakeholder alerting. The system automatically identifies the owners of the 15 dashboards that will break and notifies them via Slack/Teams before the code is merged. 3. Breaking change block. If a change impacts a Tier 1 critical report, the CI and CD pipeline is automatically blocked until a governance sign-off is received. 4. Virtual Impact Sandbox. Provide developers with a tool that simulates the change and shows a visual red zone of every broken report, allowing them to fix downstream issues before deployment. Pro tip: integrate data contracts into this process. If a developer breaks a contract that was agreed upon with the analytics team, the metadata engine should be the judge that prevents the code from ever reaching production.
Category 3. Conclusion.
Mastering metadata management transforms your data landscape from a dark, undocumented warehouse into a searchable, trusted library. When technical lineage and business context are unified, the organization gains the agility to comply with regulations, launch AI initiatives, and perform complex impact analysis with a single click. Metadata is no longer just documentation. It is the intelligence layer of the enterprise.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 3 to Category 4.
Metadata tells you what your data is and where it lives, but it does not tell you which version is the absolute truth. In a world where customer info lives in the CRM, the ERP, and the support tool, how do you know which record is correct? This is the challenge of master data management, or MDM. If metadata is the map, MDM is the golden record at the center of the compass. Let's look at Category 4.
Category 4, Master Data Management, MDM Scenarios.
Master data represents the core entities of your business, your customers, products, and suppliers. MDM is the process of resolving conflicting identities across disparate systems to create a single, authoritative version of the truth. These scenarios will test your ability to handle entity resolution, survivorship rules, and the high-stakes politics of data ownership.
Category 4, Master Data Management Scenarios.
Here are the 15 critical master data challenges we will be covering in this section. Scenario 66. Resolving customer records existing under multiple conflicting identities. Scenario 67. Standardizing product hierarchies that differ across global regions. Scenario 68. Resolving disputes between finance and sales regarding supplier master data. Scenario 69. Automating the creation of golden records at enterprise scale. Scenario 70. Managing cross-departmental conflicts caused by MDM survivorship rules. Scenario 71. Solving customer identity fragmentation across multiple CRM platforms. Scenario 72. Architecting real-time MDM synchronization for transactional systems. Scenario 73. Integrating legacy silo systems with modern, cloud-native MDM tools. Scenario 74. Harmonizing completely different product taxonomies following an acquisition. Scenario 75. Implementing AI-assisted entity resolution for high-volume datasets. Scenario 76. Replacing manual daily customer conflict resolution with automation. Scenario 77. Fixing regulatory report failures caused by inconsistent entity identifiers. Scenario 78. Implementing centralized supplier governance for global retail operations. Scenario 79. Accelerating slow MDM approval workflows to reduce onboarding delays. Scenario 80. Resolving business user disagreements over authoritative source systems. We will now dive into the expert-level answers for these MDM scenarios.
Scenario 66. Customer records exist under multiple identities across the organization, for example, J. Doe in sales and John Doe in billing. How do you resolve this?
Answer: this is a classic entity resolution challenge. I would implement a 4-step process to unify these disparate identities into a single view. 1. Standardize input data. Use parsing tools to normalize names, titles, and addresses, for example, converting APT to apartment to ensure a baseline for comparison. 2. Apply probabilistic matching. Deploy fuzzy matching algorithms that assign a similarity score based on multiple attributes like birthdate, phone number, and email. 3. Assign a universal ID. Once a match is confirmed above a 90% threshold, assign a unique enterprise customer ID that persists even if local system IDs change. 4. Build an identity crosswalk. Maintain a mapping table that links the new global ID to all original source system IDs to ensure historical continuity. Pro tip: look for shared attributes like IP addresses or household relationships. Often, two different names at the same physical address and IP are actually the same person or part of a household entity that is critical for marketing attribution.
Scenario 67. Product hierarchies differ across global regions. For example, electronics is a top-level category in EMEA, but a subcategory in NA. How do you standardize this?
Answer: standardizing global hierarchies requires a canonical model approach that balances global reporting with local operational needs. 1. Define an enterprise global taxonomy. Create a master product hierarchy that serves as the reporting standard for the executive board and global supply chain. 2. Implement hierarchy mapping. Allow regions to keep their local hierarchies for operations, but mandate a metadata map to the global taxonomy. 3. Govern attribute inheritance. Ensure that core attributes like brand or SKU are governed globally, while local attributes like language or voltage are governed regionally. 4. Establish a global product council. Form a committee with representatives from each region to approve any changes to the top-level global categories. Pro tip: use alternate hierarchies in your MDM tool. This allows you to store the data once, but view it through multiple lenses: one for North American sales, one for global finance, and one for logistics without duplicating the actual records.
Scenario 68. Finance and sales teams disagree on who owns supplier master data, leading to conflicting records for the same vendors. How do you resolve this ownership dispute?
Answer: this is a conflict of data purpose. Finance cares about banking details and tax IDs for payment, while sales cares about contact names and performance for relationship management. I would resolve this by shifting from system ownership to attribute-level stewardship. Finance is the authoritative steward for the financial attributes, and sales is the steward for the engagement attributes. We unify these into a single master record, where the MDM tool locks specific fields to their respective stewards, ensuring neither department can overwrite the other's critical data. Pro tip: use data subject stewardship rather than departmental ownership. By defining a supplier steward who reports to the CDO, but works closely with both finance and sales, you remove the political tug of war and centralize accountability.
Scenario 69. Your organization wants to automate the creation of golden records at enterprise scale. What is your architectural approach?
Answer: creating a golden record automatically requires a robust MDM engine with clear survivorship logic. I would architect the flow as follows. 1. Source system weighting. Assign a trust score to every source system. For example, the HR system is 100% trusted for employee names, but the CRM is only 60%. 2. Define field-level survivorship. Set rules for which system wins when data conflicts. For example, the most recently updated record wins for phone number, but the system of record wins for tax ID. 3. Automated conflict flagging. If two highly trusted systems provide conflicting data that exceeds a variance threshold, the system should pause the golden creation and trigger a steward review. 4. Downstream syndication. Once the golden record is created, use outbound connectors to push the corrected data back to the source systems to ensure enterprise-wide consistency. Pro tip: implement data lineage at the attribute level. Every field in the golden record should have metadata telling you exactly which system provided that specific value and when it was last verified.
Scenario 70. MDM survivorship rules are creating conflicts because one department's update is overriding another department's verified data. How do you tune these rules?
Answer: the issue here is blunt survivorship where a whole record wins regardless of the individual field quality. I would move to granular attribute survivorship. Instead of a last best record approach, I would implement validation-based winning. For example, a phone number that has been verified via SMS should always survive over a more recent phone number that was manually typed in by a salesperson. By basing survivorship on verification status and source authority rather than just recency, you significantly reduce cross-departmental friction. Pro tip: implement stewardship overrides. Give domain experts the ability to pin a specific value in the golden record. Once a value is pinned by a lead steward, No automated update from any source system can override it without a manual approval.
Scenario 71. Multiple CRMs across different business units have created severe customer identity fragmentation. How do you unify them into a single MDM hub?
Answer: fragmented CRMs are a major barrier to a 360-degree view. I would resolve this using an index-based unification strategy. 1. Centralized matching engine. Connect all CRMs to a central MDM hub that runs identity resolution as a background process. 2. Generate a global linkage key. Assign a single master ID to the customer in the MDM hub and inject that ID back into a custom field in every CRM. 3. Bidirectional sync. Ensure that when a customer's email is updated in the marketing CRM, it is validated in the MDM hub and then synced to the sales CRM. 4. Identify parent-child relationships. Use MDM to link individual contacts across different CRMs to their respective parent corporation for B2B account management. Pro tip: watch out for circular sync loops. Ensure your MDM hub has logic to detect if it is receiving its own update back from a source system, which can cause infinite data overrides and performance crashes.
Scenario 72. The enterprise wants real-time MDM synchronization for transactional systems, for example, e-commerce. How do you achieve sub-second identity resolution?
Answer: real-time MDM requires moving from batch processing to an event-driven architecture. 1. Change data capture CDC. Use tools like Debezium to stream database changes from the e-commerce platform into a Kafka topic in real time. 2. Real-time matching service. Deploy a lightweight matcher as a microservice that queries the MDM golden index the moment a new transaction arrives. 3. API-first integration. Instead of waiting for a sync, have the e-commerce platform call the MDM API to get or create customer during the checkout process. 4. Asynchronous survivorship. Run the heavy golden record merging logic asynchronously in the background so it does not slow down the customer's transaction speed. Pro tip: use an in-memory cache like Redis for your golden ID index. Querying a standard SQL database for every transaction is too slow for real time. You need the ID lookup to happen in milliseconds.
Scenario 73. Legacy mainframe systems cannot integrate with modern MDM tools via APIs. How do you include this critical data in your MDM strategy?
Answer: legacy systems are often the system of record for the oldest and most valuable customer data. Since we cannot use modern APIs, I would implement a staging file gateway. We export Delta files from the mainframe on a scheduled basis, for example, every 4 hours to a secure cloud bucket. The MDM tool then ingests and resolves this data as part of its normal cycle. To get data back to the mainframe, we reverse the process. The MDM hub generates a correction file that is consumed by a legacy batch job to update the mainframe records. It's not real time, but it ensures the legacy core remains synchronized with the modern enterprise. Pro tip: use data virtualization. Instead of physically moving all legacy data, use a virtualization layer that can query the mainframe and the MDM hub simultaneously, creating a federated view for the analyst without the need for complex, two-way ETL pipelines.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 74. Following a major acquisition, you discover the new company uses a completely different product taxonomy and SKU structure. How do you harmonize these two worlds?
Answer: harmonizing taxonomies is about creating a universal translator rather than forcing a total system rewrite. I would execute this 3-step harmonization plan. 1. Map to a canonical taxonomy instead of migrating Company B into Company A's structure. Map both into a new, neutral enterprise master taxonomy that supports future growth. 2. Build a taxonomy bridge. Create a metadata crosswalk table that allows the supply chain to see that product X in the old system is exactly the same as SKU Y in the new system. 3. Standardize attribute globalism. Identify global attributes like weight or material that must be identical, while allowing local attributes like regional marketing names to remain distinct. 4. Execute a master SKU pivot. For all new products launched post-merger, mandate the use of the new enterprise master taxonomy to prevent further fragmentation. Pro tip: use AI-powered semantic mapping. Instead of manually mapping 50,000 SKUs, use a machine learning model to analyze product descriptions and images to suggest high-confidence matches between the two disparate taxonomies.
Scenario 75. Your company wants to implement AI-assisted entity resolution to handle millions of customer records. How do you ensure the AI does not make false merges?
Answer: AI-assisted resolution requires a confidence-based workflow to maintain data integrity. I would design the system with these safeguards. 1. Clustering logic. Use the AI to group similar records into clusters based on hundreds of hidden features that traditional fuzzy matching might miss. 2. Confidence thresholding. Set a strict policy where the AI can only auto-merge if the confidence score is 99% or higher. Anything lower is flagged for a steward. 3. Active learning loops. Implement a feedback mechanism where a data steward's manual resolution of a maybe match is fed back into the model to improve its future precision. 4. Explainable resolution. Ensure the AI provides a reason code for every match, for example, matched based on rare surname and shared device ID so stewards can audit its logic. Pro tip: implement anti-matching rules. If two records share a name and address but have different middle initials or significantly different birth years, the AI should be hard-coded to never merge them, regardless of other similarities.
Scenario 76. Data stewards are stuck in a manual loop, resolving hundreds of customer conflicts daily. How do you break this cycle and move to exception-based stewardship?
Answer: the stewards are currently treating every conflict with the same level of urgency. I would implement a value-based prioritization engine. We automate the resolution of low-risk, high-confidence conflicts like minor spelling errors using predefined survivorship rules. This allows the stewards to pivot their focus to high-value exceptions such as potential duplicates in the VIP customer segment or conflicts involving legal entity identifiers. By automating the boring 80% of the work, you turn the stewardship team from data cleaners into quality strategists. Pro tip: monitor the stewardship reversal rate. If a steward manually unmerges a record that was auto-merged by the system, it indicates a flaw in your survivorship logic. Tracking this metric is the best way to prove where your automation needs tuning.
Scenario 77. Regulatory reporting is failing because your legal entity identifiers, LEIs, are inconsistent across global subsidiaries. How do you fix this for compliance?
Answer: legal entity MDM is critical for risk aggregation. I would resolve this by implementing a corporate hierarchy master data set. 1. Integrate global reference data. Connect the MDM hub to an external authoritative source such as Dun & Bradstreet or GLAIF to pull verified LEIs and tax IDs. 2. Define parent-child relationships. Map every subsidiary to its ultimate global parent to ensure the risk team can see the total exposure for a single corporate entity. 3. Enforce LEI at onboarding. Modify the procurement and sales onboarding workflows so that a new vendor or client cannot be created without a verified standard LEI. 4. Automated hierarchy refreshes. Set up a monthly sync with external registers to capture changes in corporate ownership, such as divestitures or name changes. Pro tip: use self-healing identifiers. If a local system enters a legal entity name that slightly differs from the official government registry, the MDM system should automatically overwrite the local name with the official registry name to ensure reporting consistency.
Scenario 78. A global retailer wants centralized supplier governance to prevent vendor sprawl where the same company is registered 10 times under different names. What is your strategy?
Answer: centralized supplier governance requires a front door policy for all vendor data. I would implement the following framework. 1. Global Vendor Portal. Implement a single entry point for all vendors to provide their own master data, including banking, tax, and diversity certifications. 2. Deduplication at entry. Run a search against the MDM hub the moment a new vendor is proposed to see if that entity or its parent already exists in another region. 3. Unified vendor taxonomies. Standardize spend categories globally so that laptops are not classified as IT hardware in the US and office equipment in the UK. 4. Consolidated spend reporting. Use the unified supplier master to provide the procurement team with a single view of spend, allowing them to negotiate better global contracts. Pro tip: focus on bank account validation. In modern supplier governance, the most critical data element is the bank account. Implementing a penny test or third-party bank verification as part of the MDM workflow is the best way to prevent B2B payment fraud.
Scenario 79. Customer onboarding is taking weeks because the MDM approval workflows are slow and bureaucratic. Sales is threatening to bypass the system. How do you accelerate this?
Answer: the bottleneck is usually serial approval dash, where one person has to wait for another to finish. I would redesign the onboarding into a parallel enrichment workflow. While the MDM system is auto-validating the address and tax ID, the credit team and the sales team can simultaneously add their specific attributes. I would also implement conditional approval dash if the customer is a known entity with a 100% data confidence score. They are auto-onboarded into the bronze tier immediately, while the deeper manual checks for the gold tier happen in the background without blocking the initial sale. Pro tip: use data enrichment APIs like Zoom Info or Clearbit. Instead of asking the salesperson to type in 20 fields, have them enter only the email and company domain, and let the MDM hub auto-fill the remaining 18 fields. This reduces the workload on sales and ensures higher data quality.
Scenario 80. Business users from marketing and finance cannot agree on which source system is authoritative for customer contact info. How do you break the deadlock?
Answer: deadlocks happen when we try to pick a winning system rather than a winning attribute. I would move the conversation to attribute-level authority. We agree that the CRM is the source of truth for the customer's preferred email because sales interacts with them daily. But the ERP is the authoritative source for the billing address because that's where the invoices are legally sent. By splitting the authority based on the business purpose of the data, you satisfy both departments and ensure the MDM hub always serves the correct value for the specific use case. Pro tip: implement trust scores that decay over time. A marketing opt-in from 2 years ago in the CRM should have a lower trust score than a shipping address provided in an e-commerce transaction yesterday. Let the recency and context of the data dictate the authority, not the department's politics.
Category 4 Conclusion.
Mastering master data management is about more than just merging records. It is about establishing the single source of truth that powers the entire enterprise. When you resolve identity fragmentation and automate survivorship, you move from a fractured view of your business to a golden view that enables personalized customer experiences, optimized supply chains, and accurate financial reporting.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, They all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 4 to Category 5.
But having a golden record of every customer and employee comes with massive responsibility. The more unified and accessible your data becomes, the higher the stakes for protecting it. You cannot have a single view of the customer without also having a robust strategy for their privacy. This brings us to the high-stakes world of data privacy and compliance. Let's move to Category 5.
Category 5. Data privacy and compliance scenarios.
Data privacy is no longer just a legal checklist. It is a core business requirement. In a global landscape governed by GDPR, HIPAA, and emerging AI ethics frameworks, your ability to manage consent, enforce retention, and protect sensitive information is what keeps the company out of the headlines and out of the courtroom. These scenarios will test your knowledge of global regulations and technical privacy controls.
Category 5. Data privacy and compliance scenarios.
Here are the first 13 scenarios covering privacy rights, cross-border transfers, and AI governance. Scenario 81, handling a customer's right to be forgotten request across multiple systems. Scenario 82, managing personal data distributed across a multi-cloud architecture. Scenario 83, remediating accidental exposure of sensitive data in a non-production environment. Scenario 84, providing regulators with technical proof of consent management. Scenario 85, implementing governance over training data for new AI product launches. Scenario 86, detecting and preventing unauthorized employee access to customer data. Scenario 87, navigating cross-border data transfer restrictions for global analytics. Scenario 88, achieving simultaneous compliance with GDPR, HIPAA, and regional DPDP laws. Scenario 89, managing a data breach involving a critical third-party vendor. Scenario 90, governing shadow AI tools that process confidential enterprise data. Scenario 91, enforcing automated data retention and purging policies at scale. Scenario 92, generating complete audit trails for regulator inquiries into data access. Scenario 93, preventing AI-generated outputs from exposing sensitive customer information. Scenario 94, implementing automated data classification for privacy-sensitive fields. Scenario 95, managing the risk of employees copying enterprise data into public AI tools. Scenario 96, establishing governance controls for the creation and use of synthetic data. Scenario 97, resolving conflicts between privacy restrictions and analytics requirements. Scenario 98, designing a specialized governance framework for sensitive genomic data. Scenario 99, locating dark PII across undocumented and fragmented systems. Scenario 100, implementing explainable governance for AI-driven decisioning in banking. Scenario 101, moving toward policy as code for automated privacy enforcement. Scenario 102, proving the fairness and lack of bias in AI models trained on customer data. Scenario 103, remediating overexposed datasets caused by inherited permission gaps. Scenario 104, automating the generation of evidence for regulatory compliance audits. Scenario 105, managing conflicting data retention policies across global business units. We will now dive into the deep dive answers for these high-stakes privacy and compliance scenarios.
Scenario 81. A customer invokes the right to be forgotten. How do you ensure their data is deleted across a complex landscape of CRM, data lakes, and backups?
Answer: data deletion is no longer a simple SQL delete command. It requires a coordinated orchestration across the entire architecture. I would execute the following deletion workflow. 1. Trigger the deletion via metadata. Use the global identity crosswalk to identify every system ID associated with that specific customer across the enterprise. 2. Propagate to the data lake. Issue a delete by ID command to the data lake, using ACID-compliant storage layers like Apache Iceberg or Delta Lake to physically remove the records from PAR-K files. 3. Automated API orchestration. Send a deletion signal to third-party SaaS vendors, for example, Salesforce or Marketo, to ensure the PII is purged from their managed environments. 4. Verification and certification. Generate a certificate of deletion that logs the date and systems involved, which is then stored in the privacy vault for future regulatory audits. Pro tip: do not forget about soft deletes in your source systems. Often, a record is flagged as inactive but the PII remains. Your governance tool must be configured to check for these flags and trigger a hard purge to meet legal requirements.
Scenario 82. Your company stores personal data across AWS, Azure, and Google Cloud. How do you maintain a unified privacy posture in a multi-cloud environment?
Answer: multi-cloud privacy requires an abstraction layer for governance. I would implement a centralized metadata catalog that connects to all three clouds via API. Instead of using cloud-native tools which create silos, I would use a global classification engine to apply universal PII tags across all providers. By enforcing policy as code, we ensure that a privacy rule written once, such as no PII can be stored in an unencrypted bucket dash, is automatically pushed and enforced across all three cloud environments simultaneously. Pro tip: use data residency metadata tags. If a dataset is tagged as EU resident, your multi-cloud orchestrator should be programmed to block any automated replication jobs that try to move that data into a non-compliant region like the US.
Scenario 83. Sensitive customer data is accidentally exposed in a non-production test environment. What are your immediate remediation steps?
Answer: accidental exposure in non-prod is a major compliance violation. I would follow this high-stakes incident response plan. 1. Immediate quarantine. Revoke all user access to the specific non-production environment and pause all automated ETL jobs feeding into it. 2. Identify the leak point. Trace the data lineage to find which refreshed job pulled production data into the test environment without going through the masking or anonymization layer. 3. Execute a secure purge. Permanently delete the exposed records and audit the system logs to determine if any unauthorized exports or downloads occurred during the exposure window. 4. Automate future prevention. Update the CI and CD pipeline to include a PII detection gate that automatically fails any deployment if unmasked sensitive data is detected in a non-prod schema. Pro tip: use synthetic data for testing whenever possible. By generating fake data that mimics the statistical properties of your real customers, you eliminate the risk of exposure entirely while still giving your developers high-quality data to work with.
Scenario 84. A regulator requests technical proof of consent management. How do you prove that you only process data for users who have opted in?
Answer: proof of consent requires linking legal metadata to technical data. I would demonstrate an immutable consent ledger that records every timestamped opt-in and opt-out event from our web and mobile platforms. I would then show the regulator our consent-driven filtering logic in the data warehouse. By joining our customer data with this ledger in real time, our analytics pipelines automatically exclude any user who has withdrawn consent, ensuring that no downstream report or AI model is ever trained on unconsented data. Pro tip: capture purpose of use during the consent process. Modern regulations require that you only use data for the specific reason it was collected. Storing this purpose as a metadata tag on the dataset allows you to prove you are not using shipping info for marketing analytics without permission.
Scenario 85. Your company is launching a new AI product that requires massive datasets for training. How do you govern the training data to ensure compliance?
Answer: AI governance is about ensuring the provenance and ethics of the training set. I would implement the following controls. 1. Data provenance tracking. Document the exact origin of every dataset used in the model to ensure the company has the legal right to use it for AI training. 2. Automated PII stripping. Run every training set through a de-identification pipeline to ensure that no specific individuals can be re-identified by the AI model. 3. Bias and fairness audits. Use statistical profiling to check the training data for imbalances, for example, gender or age that could lead to discriminatory model outputs. 4. Model inventory management. Link the specific version of the training data to the specific version of the AI model, allowing for a rollback if the data is later found to be non-compliant. Pro tip: implement right to be forgotten for AI. If a customer asks to be deleted, you must not only delete their raw data, but also ensure their information is unlearned or removed from future iterations of the model training set.
Scenario 86. Internal audits reveal that several employees are accessing sensitive customer data that is not required for their specific job roles. How do you fix this privilege creep?
Answer: this is a failure of static role-based access. I would move the organization toward just-in-time JIT access and least privilege enforcement. Instead of permanent access, employees must request data through a governance portal, providing a business justification. Access is then granted for a limited time, for example, 4 hours, and automatically revoked. I would also implement behavioral analytics to monitor for mass exports or unusual query patterns, triggering an automatic lockout if an employee attempts to download more data than is typical for their role. Pro tip: use attribute-based access control ABAC. Instead of assigning access to the marketing team, you assign access based on attributes like location, project ID, and clearance level, which makes your security much more granular and harder to exploit.
Scenario 87. Cross-border data transfer restrictions are affecting your global analytics. You cannot move European data to the US for processing. How do you solve this?
Answer: to enable global analytics without violating data residency laws, I would implement a federated analytics or edge governance model. 1. Deploy local processing hubs. Process the sensitive data within the local region, for example, an AWS region in Germany, to perform the initial aggregation and anonymization. 2. Transmit only insights. Move only the non-identifiable aggregated results, for example, average sales per city, to the US-based central dashboard, ensuring no PII ever leaves the EU. 3. Implement data masking at the source. Use dynamic masking or differential privacy to blur the data before it is queried by a US-based Analyst. 4. Establish standard contractual clauses (SCCs). Ensure that the legal metadata and transfer agreements are digitally linked to the datasets to prove compliance during cross-border audits. Pro tip: look into data clean rooms. These allow two parties or two regions to join and analyze data in a secure, encrypted environment where neither party can actually see or download the raw PII of the other.
Scenario 88. Your organization must comply simultaneously with GDPR, HIPAA, and multiple regional privacy laws. How do you avoid compliance burnout and maintain one standard?
Answer: I would implement a common control framework (CCF). Instead of building separate processes for every law, I would identify the high water mark, the strictest requirement across all regulations, and make that our global enterprise standard. For example, if GDPR requires deletion within 30 days, but another law allows 60, We adopt the 30-day standard globally. This simplifies our technical architecture and ensures that by meeting our internal standard, we are automatically compliant with every local regulation. Pro tip: use privacy as code to map regulatory requirements to technical tags. If a law in India changes, you update the India tag logic in your central policy engine, and it automatically updates the access and retention rules across all Indian datasets in real time.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 89. A major data breach occurs involving one of your critical third-party vendors. As the governance analyst, what is your role in the recovery?
Answer: in a third-party breach, the primary goal is damage assessment and compliance reporting. I would execute the following steps. 1. Execute the data inventory audit. Use the metadata catalog to immediately identify exactly which datasets were shared with that specific vendor and what level of PII they contained. 2. Verify encryption and masking. Confirm if the shared data was hashed or encrypted prior to transfer, which may significantly reduce our legal notification requirements. 3. Notify affected stakeholders. Work with the legal and privacy teams to generate a list of impacted customers and employees based on the lineage of the breached datasets. 4. Vendor governance review. Audit the vendor's SOC2 or ISO certifications and our right to audit clauses to determine if the breach was a result of a contractual violation. Pro tip: implement data watermarking. By adding a unique, invisible digital signature to the datasets you share with vendors, you can prove in a court of law exactly where a leaked dataset originated if it appears on the dark web.
Scenario 90. Shadow AI tools. Unauthorized Gen AI apps are being used by employees to process confidential enterprise data. How do you regain control?
Answer: you cannot stop AI usage with a total ban. You must provide a governed alternative. I would launch an internal AI gateway that is approved by security and privacy teams. This gateway would have built-in data loss prevention DLP that automatically masks or blocks any confidential information before it is sent to the LLM. I would then use network logs to identify who is still using shadow AI and transition them to the internal tool, ensuring that all AI interactions are logged, audited, and encrypted. Pro tip: add an AI clause to your acceptable use policy. Explicitly state that pasting enterprise code or customer PII into public chatbots is a security violation, and back this up with automated content scanning on your enterprise egress traffic.
Scenario 91. Your organization lacks enforcement for data retention, leading to data bloat and increased liability. How do you implement automated purging?
Answer: automated retention requires moving from policy on paper to policy in infrastructure. I would implement this three-tiered purging strategy. 1. Metadata-based expiry. Add a retention_end_date attribute to every table based on its classification, for example, 7 years for finance, 2 years for marketing. 2. Automated tiering. Use cloud storage policies to automatically move data to Glacier or archive storage once it reaches 90% of its retention life. 3. The purge trigger workflow. Create a script that identifies datasets past their expiration date and sends a confirmation ticket to the data owner. If no legal hold is placed within 10 days, the data is automatically deleted. 4. Verification logging. Maintain a permanent, immutable log of what was deleted and why, which acts as our proof of compliance for future regulatory audits. Pro tip: always check for legal holds before purging. Integrate your governance tool with the legal team's matter management system to ensure you do not accidentally delete data that is currently part of an active lawsuit.
Scenario 92. A regulator asks for a complete audit trail for every time a specific customer's data was accessed over the last year. How do you produce this?
Answer: this requires unified log aggregation. I would pull the query logs from the data warehouse, the access logs from the cloud storage buckets, and the application logs from the CRM. By using a correlation ID like the customer's global ID, I would stitch these logs together into a single chronological report showing who accessed the record, what specific fields they viewed when it happened, and from what IP address. This single audit view proves to the regulator that we have total visibility into our data processing activities. Pro tip: use immutable logging. Ensure that your access logs are written to a read-only bucket where even a system administrator cannot edit or delete them. This provides the tamper-proof evidence that regulators trust MOS-T.
Scenario 93. Generative AI outputs are accidentally exposing sensitive customer information through inference even if the raw PII was hidden. How do you prevent this?
Answer: this is indirect leakage. To prevent an AI from accidentally revealing secrets through its answers, I would implement output guardrails. 1. Real-time output scanning. Implement a proxy that scans the AI's response for patterns like credit card numbers or SSNs before the user sees the output. 2. Differential privacy in training. Use mathematical noise injection during the model training phase to ensure the AI learns general patterns without memorizing specific individual records. 3. Redaction of sensitive context. If a user asks a question about a specific customer, the guardrail should automatically redact the customer's name and replace it with a generic label like redacted_customer. 4. Prompt engineering constraints. Hard code system prompts that explicitly instruct the AI to never reveal PII or confidential strategy, regardless of how the user jailbreaks the prompt. Pro tip: test your AI with red teaming. Hire ethical hackers to try and trick the AI into revealing sensitive data. This is the only way to find hidden inference vulnerabilities before a regulator or an attacker does.
Scenario 94. Your company wants to implement automated data classification across petabytes of data to identify privacy-sensitive fields. How do you roll this out?
Answer: manual tagging is impossible at this scale. I would deploy a next-generation automated discovery and classification engine using this 4-phased approach. 1. Multi-cloud scanning. Connect the classification engine to all object storage and databases via API to perform an initial deep scan of the data landscape. 2. Contextual pattern matching. Use NLP-based models that look beyond simple rejects to understand the context of the data, for example, distinguishing a serial number from a social security number. 3. Metadata tag propagation. Implement tag inheritance, where a classification applied to a raw source automatically propagates through the lineage to all downstream assets. 4. Verification sampling. Establish a data steward queue where the AI flags low confidence matches for human verification to continuously tune the model's accuracy. Pro tip: use negative patterns. Configure your scanners to ignore known public or mock data environments to reduce the noise and processing costs, allowing the engine to focus on high-risk production zones.
Scenario 95. You discover employees are copying proprietary source code and sensitive customer data into public AI chatbots to help with their daily tasks. How do you mitigate this risk?
Answer: this is a severe data exfiltration risk. I would implement a tiered mitigation strategy. First, block access to public LLMs that do not have an enterprise privacy agreement. Second, provide a governed internal AI portal that uses an enterprise API where data is not used for model training. Third, I would implement endpoint DLP data loss prevention that detects and blocks copy-paste actions containing sensitive patterns like API keys or PII into unauthorized web domains. Pro tip: use browser-based DLP extensions. These can provide real-time pop-up warnings to employees the moment they paste sensitive data into a chatbot, educating them on the policy while preventing the leak in real time.
Scenario 96. Legal teams demand strict governance controls for synthetic data used in testing. How do you govern data that is not real but mimics reality?
Answer: synthetic data must be governed as derived intelligence rather than raw PII. I would implement these specific controls. 1. Verify differential privacy. Use mathematical audits to prove that the synthetic data does not contain leakage that could allow for the re-identification of real individuals. 2. Metadata labeling. Tag every synthetic dataset with a non-production/synthetic label to ensure it is never accidentally used for real-world financial reporting or AI decisioning. 3. Usage logging. Maintain an audit trail of who generated the synthetic data, what model was used, and which real dataset served as the statistical seed. 4. IP and ownership tracking. Document the provenance of the synthetic set to protect the organization's intellectual property if the data is shared with third-party vendors. Pro tip: periodically run a re-identification attack on your synthetic sets. If a data steward can successfully guess a real individual's identity based on the synthetic record, your privacy parameters are too low and need to be tightened.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 97. A conflict arises between the privacy team, who wants to redact all customer IDs, and the analytics team, who needs them for long-term cohort analysis. How do you resolve this?
Answer: I would propose pseudonymization using consistent tokenization. Instead of redacting the ID entirely, we replace it with a secure, salted hash, a token that remains the same across all datasets. This allows the analytics team to perform joins and track cohorts over time without ever seeing the actual, identifying PII. The detokenization key is then locked in a highly restricted privacy vault that only the DPO can access for specific legal justifications. Pro tip, use format preserving encryption (FPE). This allows you to tokenize a 16-digit credit card number into a fake 16-digit number. This prevents schema breakage in legacy analytics tools that expect a specific character length and type.
Scenario 98. A healthcare organization needs to govern genomic data. How do you handle the unique privacy challenges of data that is inherently identifying?
Answer: genomic data is the ultimate PII and requires a tiered access governance framework. 1. Granular access control. Implement attribute-based access where researchers can only see specific genetic markers without seeing the full sequence or the patient's identity. 2. Dynamic consent tracking. Link the dataset to a consent ledger that allows patients to opt out of specific types of research at any time, triggering an immediate access revocation for that record. 3. Specialized retention policies. Genomic data often has a longer legal life than standard medical records. I would implement metadata-driven archiving to meet these unique requirements. 4. Compute-to-data architecture. Instead of allowing researchers to download files, provide a trusted research environment where the analysis happens locally on the governed server. Pro tip, focus on incidental findings. Your governance policy should include a workflow for what happens when a researcher finds a life-threatening genetic marker in a dataset that was supposed to be anonymized.
Scenario 99. During a privacy audit, you realize your organization cannot locate all PII because it is hidden in undocumented dark data silos. How do you find it?
Answer: finding dark PII requires unstructured data profiling. I would use advanced scanners that can open and index not just databases, but PDFs, images using OCR, and zip files stored in object storage. I would then use cluster analysis to find datasets that look similar to our known production tables. By identifying who owns the storage bucket and tracing its ingress logs, I can bring these dark silos back into the central catalog and apply the necessary privacy classifications. Pro tip, search for orphan DB backups first. Developers often take a manual snapshot of a production database before a major update and forget to delete it. These snapshots are the #1 source of dark PII leaks during a breach.
Scenario 100. A multinational bank needs explainable governance for AI-driven credit decisions to satisfy regulators. How do you document this?
Answer: to satisfy regulators like the EU AI Act, you must prove why the AI reached a specific decision. I would implement this explainability framework. 1. Feature importance logging. For every automated decision, store the feature weights. For example, credit score had a 40% impact. Income had 30% to provide a clear audit trail. 2. Training data snapshots. Maintain a permanent link between a model version and the metadata snapshot of the exact data it was trained on to prove data integrity. 3. Adverse action transparency. Use SHAP or LIME values to generate a human-readable explanation for why a loan was denied, which can be shared directly with the customer. 4. Human-in-the-loop audit. Document every time a human steward overrode an AI decision, including the business justification for the change. Pro tip, maintain a model inventory catalog. Treat your AI models like data assets. Assign them an owner, a classification, and a risk tier so regulators can see that your most impactful models have the highest level of oversight.
Scenario 101. The company wants to move from manual checklists to policy as code for privacy governance. What does this look like in practice?
Answer: policy as code means moving your privacy rules out of PDF documents and into a version-controlled repository like Git. For example, a rule stating users in the US cannot see EU salary data is written in a language like Rego or YAML. This code is then consumed by your data platform like Snowflake or Databricks to automatically enforce masking and access at the moment of the query. This ensures that your policies are always in sync with your infrastructure and can be audited as code. Pro tip, use Open Policy Agent (OPA). It is the industry standard for cloud-native policy enforcement. By using OPA, you can apply the same privacy rules to your databases, your Kubernetes clusters, and your APIs simultaneously from a single source of truth.
Scenario 102. Regulators question the fairness of your AI models. How do you implement governance to monitor for algorithmic bias?
Answer: bias monitoring must be continuous, not a one-time check. I would implement the following algorithmic fairness controls. 1. Disparate impact analysis. Automatically calculate if the acceptance rate for one protected group is significantly lower than another across all AI outputs. 2. Frequency distribution monitoring. Set alerts for data drift dash if the incoming data for the model changes significantly from the training set. The model's fairness may decline. 3. Counterfactual testing. Regularly run what-if scenarios. For example, would the decision change if only the gender attribute was flipped, to detect hidden biases. 4. Bias remediation logs. If a bias is detected, document the technical steps taken to retrain the model or adjust the feature weights to restore fairness. Pro tip: focus on proxy variables. Even if you remove race or gender from a model, the AI might use zip code or university name as a proxy. Governance must audit the correlation between features, not just the features themselves.
Scenario 103. You find that thousands of sensitive datasets are overexposed accessible to too many users because of inherited folder permissions. How do you fix this?
Answer: this is a permission sprawl issue. I would execute a privilege reset using attribute-based access control back. Instead of relying on folder-level permissions, I would apply metadata tags, for example, PII_level_3 to the datasets. I would then create a global policy. Only users with clearance_level_3 can access data with PII_level_3. By moving the security logic from the folder to the metadata, we instantly fix overexposure regardless of how the data is moved or copied. Pro tip: implement time-bound access. For any dataset flagged as highly sensitive, access should never be permanent. Every 90 days, the user's manager should receive an automated recertification request to confirm the access is still required for the job role.
Scenario 104. Your organization wants to automate compliance evidence generation so the governance team does not have to manually prep for audits. How do you architect this?
Answer: automated evidence requires a continuous compliance pipeline that extracts data directly from your tools. I would design it as follows. 1. Real-time access logging. Stream all query and data access logs into a central audit vault that is immutable and searchable. 2. Automated DQ/privacy reports. Schedule weekly metadata scans that prove 100% of PII is classified and 100% of right-to-be-forgotten requests were fulfilled. 3. API-based evidence collection. Connect the governance tool to the HR system to prove that only current employees have active data access. 4. Compliance snapshotting. Automatically capture a snapshot of your entire governance posture lineage, catalog, and policies at the end of every quarter. Pro tip: use a trust center dashboard. By giving internal and external auditors a read-only view of these automated metrics, you eliminate the need for them to send you long spreadsheets of questions during an audit.
Scenario 105. Data retention policies differ by country and business unit, creating a conflict in your central data lake. How do you enforce these rules at scale?
Answer: I would use metadata-driven partitioning. Instead of hard-coding the purge logic into 50 different pipelines, I would tag every record or dataset with a country_ID and a retention_class, for example, finance_Europe. A central retention engine then runs daily, querying the metadata to see which records have passed their specific local expiration date and purging them automatically. This allows you to manage one central data lake while respecting the unique legal nuances of every global region. Pro tip: implement global overrides. Ensure your retention engine has a legal hold flag. If the legal team identifies a specific project or country as being under audit, you can pause the automated purges for that specific metadata tag with a single click without stopping the entire system.
Category 5 Conclusion.
Mastering data privacy and compliance is the ultimate test of a governance professional. It requires balancing the aggressive data needs of the business with the strict, often conflicting demands of global regulators. When you move from manual checklists to automated, policy-driven enforcement, you do not just protect the company from fines, you build a foundation of digital trust that becomes a competitive advantage.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 5 to Category 6.
But protecting data is impossible if you do not have total visibility into where it lives. In the modern era, that where is almost always a complex web of multi-cloud environments, lakehouses, and streaming pipelines. The speed of the cloud is the enemy of traditional, slow-moving governance. We must now explore how to govern the modern data platform without killing the agility that the cloud provides. Let's move to Category 6.
Category 6. Cloud and Modern Data Platform Scenarios.
Modern platforms like Snowflake, Databricks, and Cloud-Native Object Storage have revolutionized data scale, but they have also created data sprawl at an unprecedented level. Governing these environments requires a shift toward governance as code and deep integration with DevOps. These scenarios will test your ability to manage multi-cloud complexity, lakehouse architectures, and the rising costs of unmanaged cloud data.
Category 6. Cloud and Modern Data Platforms.
Here are the 20 critical scenarios covering multi-cloud, Snowflake, Databricks, and cloud-native governance. Scenario 106. Designing a strategy for migrating from on-premise to multi-cloud architecture. Scenario 107. Resolving conflicting governance policies across AWS, Azure, and GCP. Scenario 108. Troubleshooting broken data lineage during complex cloud ETL transformations. Scenario 109. Managing shadow cloud where teams provision databases without approval. Scenario 110. Implementing governance and security for Snowflake data sharing. Scenario 111. Closing governance visibility gaps in Kubernetes-based data workloads. Scenario 112. Remediating duplicate datasets introduced during a massive cloud migration. Scenario 113. Curbing data sprawl caused by self-service cloud provisioning. Scenario 114. Architecting centralized governance across a unified lakehouse architecture. Scenario 115. Enforcing governance checks on real-time streaming data pipelines. Scenario 116. Unifying metadata across teams using different cloud-native cataloging tools. Scenario 117. Using governance to curb rising cloud costs from unmanaged datasets. Scenario 118. Preventing AI workloads from consuming uncertified datasets in the cloud. Scenario 119. Standardizing inconsistent governance controls between dev, test, and prod. Scenario 120. Automating governance enforcement within Terraform and IAC pipelines. Scenario 121. Enforcing data retention policies within cloud-native object storage. Scenario 122. Implementing and governing Databricks Unity Catalog at enterprise scale. Scenario 123, discovering and managing sensitive data hidden within SaaS applications. Scenario 124, mitigating compliance risks introduced by multi-cloud data replication. Scenario 125, integrating FinOps with governance to map data costs to business value. We will now dive into the deep dive answers for these cloud and modern platform scenarios.
Scenario 106. Your enterprise is migrating from a legacy on-premise environment to a multi-cloud architecture. How do you ensure governance is not lost in transition?
Answer: migration is the perfect time to clean before you move. I would implement a migration gate where no dataset is moved to the cloud unless it has a verified owner, a clear classification, and a documented business purpose. I would also move away from system-specific controls toward a cloud-agnostic governance layer. By using a centralized catalog that manages metadata across all providers, we ensure that our policies remain consistent whether the data eventually lands in AWS, Azure, or GCP. Pro tip: do not perform a lift and shift of your old problems. Use the migration to implement schema on read governance. Tag your data at the source, and use your cloud platform's discovery tools to verify the tags automatically as the data hits the S3 or blob storage buckets.
Scenario 107. Governance policies differ wildly between your AWS, Azure, and GCP environments. How do you standardize them?
Answer: to prevent policy fragmentation in a multi-cloud setup, I would implement a global policy engine approach. 1. Establish a unified policy framework. Define high-level security and privacy rules that are cloud-blind. For example, all PII must be masked for non-admin users. 2. Map to cloud-native IAM. Use a tool like Apache Ranger or a specialized vendor to translate these global rules into AWS IAM, Azure RBAC, and GCP IAM policies automatically. 3. Centralize logging and auditing. Stream all access logs from all three clouds into a single security lake like Snowflake or an ELK stack for a unified audit view. 4. Automated policy drifts checks. Run daily scans to ensure no cloud-specific local admin has created an override that violates the global governance standard. Pro tip: focus on identity federation. Ensure you have a single source of truth for identities like Okta or Azure AD across all clouds. Governance fails in multi-cloud environments when the same user has 3 different IDs across 3 different platforms.
Scenario 108. Data lineage breaks during cloud ETL transformations, especially when moving between different cloud services. How do you maintain traceability?
Answer: lineage breaks occur when metadata is not passed between hops. I would resolve this by implementing open lineage standards. 1. Adopt open lineage metadata. Use the Open Lineage API to ensure that every tool in the stack, for example, Airflow, Spark, dbt, emits a standard job event metadata packet. 2. Implement metadata injection. For black box transformations, inject a correlation ID into the data header or file metadata so the downstream system can link it back to the source. 3. Use a lineage-aware catalog. Deploy a catalog that can stitch these events together, visualizing the path from an AWS S3 bucket through a Databricks notebook into a Snowflake table. 4. Automated lineage verification. Schedule regular probe jobs that track a dummy record through the entire pipeline to verify the lineage map is still accurate. Pro tip: watch out for temporary tables in your ETL scripts. Most lineage tools ignore temp objects, which can create a massive gap in your map. Instruct developers to use CTAS statements with specific naming conventions that the lineage scanner can recognize.
Scenario 109. Business units are bypassing IT and provisioning their own cloud databases, Shadow Cloud, without governance approval. How do you rein this in?
Answer: Shadow Cloud is a response to IT being too slow. I would pivot from policing to provisioning. I would create a self-service governance portal where a business user can request a database with one click. Behind the scenes, this portal uses Terraform to provision the database with governed defaults already built in, including pre-configured encryption, automated backups, and a connection to the central metadata catalog. By making the governed path the fastest path, you eliminate the need for shadow systems. Pro tip: use cloud billing alerts as a discovery tool. Monitor your enterprise cloud bill for new, unrecognized resource tags. If you see a spike in costs from a database that is not in your catalog, you have found a shadow system. Reach out to the owner to onboard them rather than shutting them down.
Scenario 110. Your organization wants to use Snowflake data sharing with external partners. How do you govern data that leaves your direct control?
Answer: data sharing requires shifting governance from server side to object side. I would implement the following controls. 1. Implement row-level security RLS. Ensure the shared secure view only contains the specific rows the partner is contractually allowed to see. 2. Data masking at source. Apply dynamic masking to all sensitive columns so the partner sees John XXX instead of John Doe directly in their own Snowflake account. 3. Sharing metadata tags. Tag all shared objects as external_share and link them to a specific data sharing agreement in the metadata catalog. 4. Audit share usage. Regularly monitor the share logs to see how often the partner is querying the data and if they are attempting to export it into their own local storage. Pro tip: use secure functions instead of secure views for complex sharing. A secure function allows the partner to query the result of a calculation like a credit score without ever giving them access to the raw underlying data like salary or debt.
Scenario 111. Kubernetes-based data workloads like Spark on K8s are creating visibility gaps for governance. How do you monitor these ephemeral containers?
Answer: the ephemeral nature of Kubernetes is the challenge. A container can exist for 5 minutes and disappear. I would implement sidecar metadata agents. Every time a data job is spun up in a pod, a sidecar container runs alongside it, capturing the job's input/output metadata and streaming it to the central catalog in real time. This ensures that even after the pod is destroyed, we have a permanent record of what data was accessed, what transformations were run, and who initiated the job. Pro tip: tag your Kubernetes namespaces with governance metadata. By assigning an owner and privacy tier to the namespace itself, any data job running within that namespace automatically inherits those governance attributes for its audit trail.
Scenario 112. A cloud migration has introduced massive amounts of duplicate datasets because different teams migrated the same on-premise tables. How do you clean this up?
Answer: duplicate cloud data is a cost and trust killer. I would implement a deduplication and redirection strategy. 1. Identify duplicates via hash. Run a hash-based comparison on the schemas and row counts of newly migrated tables to identify 100% matches. 2. Rank the master copy. Choose the dataset with the highest freshness and completeness scores as the official version. 3. Implement soft redirects. Instead of deleting the duplicates, replace them with a view that points to the master table, ensuring downstream reports do not break. 4. Automated cleanup. After 60 days of monitoring usage logs on the soft redirects, decommission the duplicate physical storage and update the catalog. Pro tip: use upstream profiling. Most duplicates happen because of redundant ETL pipelines. If you find 2 identical tables, trace them back to the source. Usually, you will find 2 identical Airflow jobs that need to be consolidated into one.
Scenario 113. Data sprawl is increasing rapidly because self-service cloud provisioning allows anyone to create a sandbox. How do you balance agility with control?
Answer: the solution is automated lifecycle management for sandboxes. I would implement a policy where every self-service sandbox has a mandatory 30-day expiration date. If the user does not actively renew the sandbox or provide a business justification for permanent storage, the data is automatically moved to cold storage and eventually purged. We provide the agility to experiment, but we enforce the discipline of clean as you go through automated infrastructure. Pro tip: implement sandbox quotas. Instead of unlimited storage, give every department a data budget in GBs. When they hit the limit, they must delete old, unmanaged datasets before they can create new ones. This forces the business to govern their own sprawl.
Scenario 114. Your company is moving to a lakehouse architecture, for example, Databricks or Snowflake. How do you govern data that lives both as files and as tables?
Answer: lakehouse governance requires unified metadata that bridges the gap between the data lake and the data warehouse. 1. Centralize the metastore. Use a unified catalog like Hive Metastore or Unity Catalog that tracks both managed tables and external tables files. 2. Implement file-level classification. Use an AI scanner to classify the raw files par-k, CSV in the S3/blob layer before they are even registered as tables. 3. Enforce table-level access. Apply the same security policies masking, RLS to the SQL layer regardless of whether the underlying data is a Delta table or a raw file. 4. Audit direct file access. Ensure that users cannot bypass the Lakehouse's SQL security by going directly to the storage bucket to download the raw files. Pro tip: focus on compaction and partitioning. In a Lakehouse, poor partitioning is not just a performance issue, it is a governance issue. If data is not partitioned by date or region, enforcing retention and residency becomes a manual, high-risk nightmare.
Scenario 115. Streaming data pipelines are bypassing traditional governance checks because the data is too fast for batch-based tools. How do you govern data in motion?
Answer: you must implement schema enforcement at the source. I would use a schema registry like Confluent where every producer must register their data format before they can publish to a Kafka topic. If the data packet does not match the registered schema, or if it contains unclassified PII, it is automatically rejected and sent to a dead letter queue. Governance moves from a post hoc audit to a real-time gatekeeper within the stream itself. Pro tip: implement stream observability. Use metadata to track the velocity and volume of the stream. A sudden spike in volume or a change in the entropy of a field often signals a data quality or security issue that needs to be caught in seconds, not hours.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 116. Different teams are using different native catalogs: AWS Glue, Azure Purview, etc. How do you create an enterprise view?
Answer: this is a metadata silo problem. I would resolve this by implementing a catalog of catalog strategy. 1. Select a federated catalog. Deploy an enterprise-grade catalog like Collabra or Atlan that can crawl and ingest metadata from cloud-native catalogs via API. 2. Establish metadata standards. Mandate that all teams use a common set of global tags, for example, PII_level in their native cloud tools. 3. Unify the business glossary. Ensure that while technical metadata is cloud-native, the business definitions are centralized and mapped to all platforms. 4. Implement cross-cloud lineage. Use the federated catalog to stitch together the hops between AWS Glue and Snowflake to show the full end-to-end journey. Pro tip: do not try to sync everything to the central catalog. Sync only the certified or production assets. Let the native cloud catalogs handle the noise of dev/test environments, while the enterprise catalog focuses on trust.
Scenario 117. Cloud costs are rising due to redundant and unmanaged datasets. How can governance help the FinOps team reduce waste?
Answer: governance provides the context that FinOps lacks. FinOps can see that a 50 terabytes table is expensive, but only governance knows if that table is critical or trash. I would integrate the catalog with the Cloud Billing API. We then flag any high-cost dataset that hasn't been queried in 90 days or has zero data quality checks. By identifying this zombie data, we can confidently tell the business to delete or archive it, directly reducing the cloud bill by 20% to 30%. Pro tip: implement unit cost of data. Calculate the cost of storing and processing each specific data product. When a department sees that their marketing dashboard costs $5,000 a month just to store, they become much more disciplined about what data they truly need.
Scenario 118. AI workloads are consuming uncertified and potentially biased datasets from the cloud. How do you implement a governance gate for AI?
Answer: to protect AI integrity, you must govern the ingestion point of the training models. 1. Mandatory certification check. Configure the AI training environment to only mount datasets that have a certified status in the metadata catalog. 2. Automated bias profiling. Run a mandatory profiling job on any dataset before it is fed into an LLM to check for class imbalances or sensitive proxy variables. 3. AI model metadata. Document the data lineage for every model version, showing exactly which datasets were used for training and who approved them. 4. Implement a model registry. Use a tool like MLflow and link it to your governance catalog to ensure that only governed models are deployed to production. Pro tip: use data contracts for AI. If the underlying data for a model changes significantly, schema drift or quality drop, the contract should automatically pause the model's inference to prevent hallucinations or wrong decisions.
Scenario 119. Governance controls are inconsistent between your dev, test, and production cloud environments. How do you ensure environment parity?
Answer: inconsistency leads to security leaks and deployment failures. I would implement governance as code, where the security and masking policies are stored in a Git repository and deployed via the CI and CD pipeline. This ensures that the exact same masking logic used in production is also applied to the test environment. I would also use environment scanners to detect any manual overrides. If a developer manually opens a S3 bucket in dev that should be restricted, the scanner identifies and reverts the change automatically. Pro tip: use Terraform modules for data storage. Instead of letting teams write their own storage code, provide a governed storage module that has encryption, logging, and access control pre-configured. If it is not built with the module, it is not allowed in any environment.
Scenario 120. Your company wants automated governance enforcement within Terraform pipelines. How do you design these infrastructure guardrails?
Answer: policy as code in the IAC pipeline prevents non-compliant infrastructure from ever being built. I would design the flow as follows. 1. Define OPA policies. Write rules in Rego Open Policy Agent like no S3 bucket can be created without public access block enabled. 2. Integrate Terraform plan checks during the CI and CD run. The pipeline executes a Terraform plan and pipes the output into the OPA engine for validation. 3. Automated pipeline failure. If the plan violates a high-severity governance rule like missing encryption, the pipeline automatically fails and blocks the apply step. 4. Metadata tag enforcement. Ensure that any resource created via Terraform is automatically tagged with owner, project, and cost center metadata. Pro tip: do not just block-provide correction advice. If a developer's pipeline fails due to a governance rule, the error message should include a link to the specific documentation or code snippet needed to fix it.
Scenario 121. Data retention policies are not enforced in your cloud object storage S3/GCS, leading to legal risk. How do you automate this at the storage layer?
Answer: you should use cloud-native lifecycle policies. Instead of building a custom script, I would configure S3 lifecycle rules that are driven by tags. Any bucket tagged as retention, 7 years is automatically configured to transition objects to Glacier after 1 year and permanently delete after 7 years. I would also implement object lock for compliance-critical data to ensure that not even a system administrator can delete the records before the retention period expires. Pro tip: implement purge observability. Have a dashboard that tracks pending deletions. Before the automated purge happens, give the data owners a 30-day window to legal hold specific files if they are needed for an active audit or lawsuit.
Scenario 122. Your enterprise is implementing Databricks Unity Catalog. How do you migrate thousands of unmanaged tables into this new governed framework?
Answer: migrating to Unity Catalog UC is an identity and metadata project. I would execute the migration as follows. 1. Unify identities. Ensure that all users and groups are synced from your central IDP like Azure AD to the Databricks account level before enabling UC. 2. External location governance. Register your S3/ATL storage as external locations within UC to bring unmanaged files under the governance umbrella. 3. Automated sync commands. Use Databricks native sync or upgrade commands to move legacy Hive Metastore tables into the new UC Metastore while preserving metadata. 4. Implement row and column security. Use UC's native SQL-based masking and filtering to replace legacy complex Python-based security logic. Pro tip: use discovery mode. Enable Unity Catalog in a read-only audit mode for the first 30 days. Use the query insights to see who is accessing what, and use that data to design your security roles before you enforce them.
Scenario 123. SaaS applications like Salesforce or Workday contain unmanaged sensitive data that is not in your central catalog. How do you govern SaaS silos?
Answer: SaaS data is often the most sensitive but the hardest to govern. I would implement SaaS metadata connectors. I would use a catalog that can pull custom object metadata and permission sets directly from the SaaS APIs. By bringing this metadata into the central catalog, we can see the lineage between our Salesforce fields and our Snowflake dashboards. I would also implement CASB Cloud Access Security Broker to monitor for unauthorized data exports or bulk downloads from these SaaS applications. Pro tip: focus on shadow SaaS. Use your SSO Okta/Azure AD logs to find every application that employees are logging into. You will often find free or personal SaaS accounts that are being used to process company data without any governance oversight.
Scenario 124. Multi-cloud replication syncing data between AWS and Azure is creating compliance risks. How do you govern data in transit between clouds?
Answer: cross-cloud replication often creates governance drift. I would implement the following sync controls. 1. Policy replication. Ensure that whenever a dataset is replicated, its metadata tags and access policies are replicated alongside it to prevent security gaps in the new cloud. 2. Encryption in transit. Mandate that all cross-cloud traffic must move through a secure VPN or private link with mandatory TLS 1.3 encryption. 3. Residency validation. Implement a regional filter dash if a dataset is tagged as EU only. The replication tool should be hard-coded to block any sync attempts to a US-based cloud region. 4. Replication audit logs. Maintain a single ledger that shows exactly when a file was copied, who initiated the sync, and the checksum verification of the destination file. Pro tip: be wary of egress costs. Governance should not just focus on security but on architectural integrity. If teams are replicating data simply because they find one cloud's UI easier to use, governance should intervene to stop the unnecessary cost and risk.
Scenario 125. Your company wants to integrate FinOps and governance. How do you use metadata to prove the business value of cloud data spend?
Answer: the goal is to move from total cost to cost per insight. I would map cloud resource tags to governance metadata. We link the cost of a Snowflake warehouse or an S3 bucket to the specific data product it supports. If a data product costs $10,000 per month but is only used by 2 people for a low-priority report, governance provides the evidence to decommission it. Conversely, if a high-cost asset is used by the CEO revenue dashboard, we prove the value justified the spend. Pro tip: implement data ROI scores. Use the catalog to track the number of users, the data quality score, and the business criticality of a dataset. Compare this against its cloud monthly bill. Any dataset with high cost and low usage/quality is your first target for cost optimization.
Category 6 Conclusion.
Mastering modern data platforms is about moving from static, manual governance to automated, infrastructure-integrated controls. When governance is built directly into the cloud fabric and the CI and CD pipeline, it stops being a bottleneck and starts being a catalyst for scale. The goal is total visibility across the multi-cloud landscape without ever compromising on the speed of the business.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 6 to Category 7.
But infrastructure and tools are only as good as the operations that run them. Behind every cloud database and every privacy policy, there are humans who must own the data and technical maps that show where it travels. We must now dive into the engine room of governance, lineage, stewardship, and security. This is where the strategy meets the daily reality of the data Analyst. Let's explore Category 7.
Category 7 Operational Core, Lineage, Stewardship, and Security.
Category 7 covers the tactical pillars that ensure data is traceable, accountable, and secure. Without lineage, you are flying blind. Without stewardship, no one is responsible. And without security, you are one click away from a disaster. These scenarios test your ability to build culture, automate complex maps, and enforce zero-trust access across the enterprise.
Category 7 Operational Core Scenarios.
Here are the 20 critical scenarios covering the operational heart of data governance. Scenario 126, delivering complete financial lineage for high-stakes regulatory audits. Scenario 127, resolving dashboard breakages caused by undocumented upstream schema changes. Scenario 128, empowering analysts to independently identify complex upstream data dependencies. Scenario 129, implementing real-time lineage visualization for modern data pipelines. Scenario 130, documenting and mapping black box ETL jobs that transform data silently. Scenario 131, overcoming engineering resistance to lineage documentation and metadata tasks. Scenario 132, transitioning from manual mapping to automated lineage extraction tools. Scenario 133, driving adoption when business users refuse stewardship responsibilities. Scenario 134, empowering data stewards with the authority to enforce enterprise policies. Scenario 135, modernizing stewardship from email-based approvals to automated workflows. Scenario 136, designing a federated stewardship model for decentralized business units. Scenario 137, automating duplicate record resolution to free stewards for strategic tasks. Scenario 138, governing and restricting sensitive data access for third-party contractors. Scenario 139, auditing and standardizing inconsistent role-based access controls RBAC. Scenario 140, moving toward attribute-based access control ABAC for granular security. Scenario 141, detecting and remediating privilege creep and excessive permissions. Scenario 142, implementing a zero-trust data governance framework for the enterprise. Scenario 143, integrating legacy systems lacking APIs into the modern governance stack. Scenario 144, implementing and governing data contracts within a decentralized data mesh. Scenario 145, designing governance for unstructured data, images, video, and audio. We will now dive into the deep dive answers for these core operational scenarios.
Scenario 126. Regulators demand complete lineage for financial reporting to prove data integrity. How do you deliver this?
Answer: delivering regulatory-grade lineage requires a source-to-report map that is both visual and verifiable. I would execute the following steps. 1. Automated code parsing. Use a lineage tool that scans the SQL in your ETL jobs, for example, DBT or Informatica, to automatically generate the technical map. 2. Business technical mapping. Overlay the technical hops with business terms so an auditor can see how source_col_ becomes quarterly revenue. 3. Incorporate manual overrides. For legacy or black box systems where code cannot be parsed, manually document the logic and link it to the automated map. 4. Lineage attestation. Require data owners to sign off on the accuracy of the lineage path annually, providing the regulator with a certified audit trail. Pro tip: focus on hop counting. Regulators often ask exactly how many times a data element was transformed. Being able to show a transformation log for every hop in the lineage graph is the ultimate proof of integrity.
Scenario 127. A critical executive dashboard breaks during a board meeting after an undocumented schema change in an upstream system. How do you remediate and prevent this?
Answer: this is a failure of impact analysis. My immediate remediation is to use the data catalog's lineage map to find the specific upstream table that changed and roll back the dashboard to a cached version of the data. To prevent this, I would implement data contracts and pre-deployment checks. Any developer attempting a schema change in a source system would trigger an automated alert showing them exactly which downstream dashboards will break. The CI/CD pipeline would block the change until the dashboard owner provides a digital sign-off. Pro tip: implement schema drift monitoring. Use an observability tool that alerts you the moment a column is added, dropped, or renamed in a source system before the ETL job runs. This allows you to fix the pipeline in the staging phase before it ever reaches the board's dashboard.
Scenario 128. Analysts cannot identify upstream dependencies, leading them to use the wrong versions of tables. How do you empower them?
Answer: dependency visibility should be self-service. I would implement the following features in the data catalog. 1. Visual dependency graph. Provide a one-click upstream view in the catalog that shows every source table feeding into the current dataset. 2. Certification badges. Clearly mark authoritative datasets so analysts can instantly distinguish between a sandbox table and a production source. 3. Impact notification. Allow analysts to subscribe to a dataset. If any upstream dependency changes, they receive an automated Slack or email alert. 4. Downstream usage metrics. Show how many other reports are using this table. High usage is a strong metadata signal of a trusted dependency. Pro tip: use Lineage integrated SQL editors. If an analyst is writing a query in Snowflake or Databricks, integrate a plugin that shows them the lineage and trust score of the tables they are typing in real time.
Scenario 129. Your company wants real-time lineage visualization for streaming data Kafka or Flink. How do you architect this?
Answer: streaming lineage is complex because the map changes every second. I would use the Open Lineage standard to capture job events from the stream processors. As a message moves through Kafka topics and Flink jobs, each transformation emits a metadata packet to a central lineage collector. This collector then stitches the events into a dynamic lineage map. This allows us to see exactly how data is being transformed in flight and catch errors in the stream before the data ever lands in the warehouse. Pro tip: focus on topic to table lineage. The biggest gap in streaming is often the transition from the Kafka topic to the persistent table. Ensure your sync connector is instrumented to report this final hop to the catalog.
Scenario 130. ETL jobs are transforming data without any documentation. How do you uncover and map these black box processes?
Answer: uncovering black boxes requires reverse engineering the metadata. I would follow this investigative approach. 1. Query log parsing. Analyze the data warehouse access logs to see which service accounts are reading from table A and writing to table B. 2. Analyze transformation patterns. Compare the entropy and distribution of the source versus target. If the data looks similar but is aggregated, you have found an aggregation hop. 3. Source code scanning. Use an AI-based code parser to read through Python or Java ETL scripts and extract the logic into a human-readable flow diagram. 4. Interview the hero developers. Identify the engineers who created the jobs and conduct knowledge transfer sessions to document the logic before they leave the company. Pro tip: use data fingerprinting. Assign a unique hash to a batch of data at the source. If you find that same hash, or a derivative in a downstream table, you have mathematically proven the lineage even without seeing the code.
Scenario 131. Data engineers resist lineage documentation because it slows down their delivery speed. How do you resolve this cultural friction?
Answer: you do not solve this by asking engineers to do more work. You solve it by making documentation a byproduct of coding. I would implement automated lineage extraction, where the lineage is harvested directly from their DBT models or Airflow DAGs. I would also show them the developer ROI- proving that when they have good lineage, their own on-call troubleshooting time for broken pipelines is reduced by 50%. When they see that documentation saves them time during an incident, the resistance disappears. Pro tip: implement documentation as code. Let engineers write their metadata in the same YAML files they use for their pipelines. If the metadata is missing, the pull request is automatically rejected by the CI and CD bot, making documentation a standard part of their existing workflow.
Scenario 132. Your organization wants to transition from manual lineage to automated extraction. What are the key requirements for the new tool?
Answer: an automated lineage tool must be dialect-aware, and API first. I would prioritize these 4 requirements. 1. Multi-dialect SQL parsing. The tool must be able to read and understand complex SQL from Snowflake, BigQuery, and Legacy SQL Server simultaneously. 2. Cross-platform stitching. It must be able to connect the dots when data moves from an S3 bucket file into a data warehouse table. 3. Column-level granularity. A table-to-table map is not enough. We need to see exactly which source column feeds into which report field. 4. Open API support. The tool must allow us to push custom metadata for those systems that cannot be automatically scanned. Pro tip: look for active lineage capabilities. The best tools do not just show you a map. They alert you when the actual data flow differs from the documented flow, catching shadow pipelines immediately.
Scenario 133. Business users refuse stewardship responsibilities, claiming they are too busy for data tasks. How do you drive adoption?
Answer: stewardship fails when it feels like a volunteer job. I would work with HR and leadership to make stewardship a formalized role included in their annual performance reviews. I would also incentivize through empowerment, showing them that by being a steward, they get priority access to new data features and a seat at the table for AI strategy. By framing stewardship as a career accelerator rather than a task, you attract the highest performing business users to the role. Pro tip: provide a stewardship toolkit. Give them dashboards that show the data health of their domain. When they see a red score for their own department's data, their natural business instinct to fix the problem kicks in much faster than an IT risk.
Scenario 134. Data stewards lack the authority to enforce policies. They find errors but cannot force the IT team to fix them. How do you empower them?
Answer: empowerment comes from governance decision rights. I would implement the following structural changes. 1. Executive sponsorship. Ensure every steward is backed by a domain owner, for example, a VP of finance who has the budget to prioritize data fixes. 2. Veto power over data products. Give stewards the authority to block a new data product from being launched if it does not meet the domain's quality standards. 3. Service level agreements (SLAs). Establish a formal agreement where IT must resolve steward-flagged critical data errors within a specific timeframe, for example, 48 hours. 4. Seat on the change advisory board. Include lead stewards in the technical review meetings for any system changes that impact their data domain. Pro tip: create a governance escalation path. If a steward and an engineer disagree, have a clear path to the governance council for a final decision. Knowing there is a judge ensures that both sides work harder to find a compromise.
Scenario 135. Stewardship workflows currently depend entirely on manual email approvals and spreadsheets. How do you modernize this?
Answer: email is where governance goes to die. I would move all stewardship actions into a workflow orchestration tool like ServiceNow or a native catalog workflow. When a user requests access or a new term definition, a ticket is automatically routed to the steward's dashboard. The steward can approve or reject with one click, and the system automatically updates the catalog and the database permissions. This creates a permanent, searchable audit trail of every governance decision ever made. Pro tip: use Slack/Teams integration. Most stewards spend their day in chat apps. By allowing them to approve a metadata change directly from a Slack notification, you reduce the approval latency from days to minutes.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 136. Your company wants federated stewardship for decentralized business units. How do you maintain consistency?
Answer: federated stewardship requires a hub-and-spoke model. I would design the operating model as follows. 1. The central hub, a small central team, defines the global standards, for example, how to tag PII, and provides the unified tooling. 2. The spokes, domain stewards, business units own the local context. They define their own terms and quality rules within the global framework. 3. Cross-domain councils hold monthly meetings where stewards from different units, for example, sales and finance, align on overlapping data like customer ID. 4. Automated consistency audits run monthly reports to find glossary drifts where two domains have defined the same term differently and flag them for alignment. Pro tip: use stewardship tiering. Give lead stewards the authority to approve global changes, while junior stewards focus on local data cleanup. This ensures that only the most experienced voices are changing the enterprise-wide standards.
Scenario 137. Data stewards are overwhelmed. spending 90% of their time manually resolving duplicate customer records. How do you fix this burnout?
Answer: this is a failure of automated entity resolution. I would implement an AI-first MDM strategy. I would train a model to resolve 80% of high-confidence duplicates automatically based on historical steward decisions. For the remaining 20% of ambiguous cases, I would provide the steward with a match recommendation dash showing them exactly why the AI thinks two records are a match. This shifts the steward's role from data searcher to final arbitrator, dramatically reducing their manual workload. Pro tip: measure stewardship velocity. Track how many conflicts a steward resolves per hour. If the number is low, it usually means their resolution interface is poorly designed or the data is too messy for the current rules. Use this metric to justify better automation tools.
Scenario 138. Sensitive data is currently accessible to third-party contractors with broad permissions. How do you implement contractor governance?
Answer: contractor access must be temporal and masked. I would implement the following security controls. 1. Mandatory dynamic masking. All contractors see masked versions of PII, for example, XXX1234 by default, regardless of their role. 2. Time-bound access TTL. Grant permissions that automatically expire on the contractor's contract end date synced from the HR system. 3. Isolated VDI environments. Require contractors to access data only through a virtual desktop where copy-paste and downloads to their local machine are disabled. 4. Enhanced query logging. Tag all contractor queries in the audit log for high-frequency review by the security team. Pro tip: implement data clean rooms for contractors. Instead of giving them access to your warehouse, they upload their code to a secure clean room where it runs against the data, and they only receive the aggregated results.
Scenario 139. An audit reveals that role-based access controls RBAC are inconsistently applied across different departments. How do you standardize security?
Answer: inconsistency happens when departments create their own local roles. I would implement an enterprise role catalog. I would define a set of global personas, for example, junior analyst, lead scientist, executive. These personas have standardized access levels that apply across all platforms: Snowflake, Tableau, AWS. Departments can then map their employees to these global personas. By centralizing the role definition but federating the role assignment, you ensure that every junior analyst in the company has the same security restrictions. Pro tip: use inheritance analysis. Often, a user is in a restricted group, but also in a public group that gives them backdoor access. Run a monthly effective permission report to find these hidden overlaps and flatten the role hierarchy.
Scenario 140. Your company wants to move from RBAC to attribute-based access control ABAC. What is the implementation roadmap?
Answer: ABAC is more granular but requires high-quality metadata. I would follow this implementation roadmap. 1. Enrich metadata tags. Ensure 100% of datasets have sensitivity and domain tags, for example, sensitivity, PI, domain, finance. 2. Enrich user attributes. Synchronize user attributes from the HR system, for example, location, France, clearance, level 2. 3. Define global policies. Write a single policy. Users can only see data if user.location is equal to data.region, and user.clearance is greater than or equal to data.sensitivity. 4. Deploy a policy orchestrator. Use a tool like Immuta or Privesera that can enforce this single policy across your entire data stack in real time. Pro tip: ABAC is perfect for data sovereignty. Instead of creating 40 different roles for 40 countries, you create one policy that uses the user.country attribute to automatically filter the data, saving thousands of hours in role management.
Scenario 141. Privilege creep is rampant. Employees keep permissions from old roles after they move departments. How do you fix this?
Answer: this is a failure of the user lifecycle process. I would implement automated access reviews and role-triggered revocation. When the HR system records a department change or a title change, it should automatically trigger a workflow in the governance tool to revoke all non-standard permissions for that user. The user's new manager then receives a notification to request only the specific data needed for the new role. This reset on move policy is the only way to stop privilege creep at scale. Pro tip: Implement dormancy deletion. If a user hasn't queried a specific dataset in 60 days, the system should automatically revoke that specific permission. If they truly need it, they can re-request it in 30 seconds via the self-service portal.
Scenario 142. Your organization wants to implement Zero Trust Data Governance. What are the technical pillars of this framework?
Answer: Zero Trust assumes that identity alone is not enough to grant trues. I would implement these 4 pillars. 1. Continuous authentication. Every single query is verified against the user's current risk score, for example, location, device health, time of day. 2. Micro-segmentation. Data is partitioned into micro-zones where access to one table does not automatically grant access to the table next to it. 3. Just-in-time JIT access. Access is never permanent. It is granted only for the duration of the specific task and then instantly revoked. 4. Full payload logging. We log not just who accessed what, but the actual query results in a hashed format to detect if a legitimate user is attempting to exfiltrate data. Pro tip: use contextual MFA. If a user is accessing a highly sensitive dataset from an unusual location, the system should trigger a secondary multi-factor authentication challenge at the moment of the query.
Scenario 143. Legacy systems mainframes lack APIs for modern governance integration. How do you bring them under the governance umbrella?
Answer: you cannot modernize the mainframe, so you must govern the export. I would implement a governed landing zone. All data leaving the mainframe must pass through a specialized gateway that performs automated PII classification and applies a metadata fingerprint to the files. This gateway then registers the data in the central catalog. By governing the point of exit from the legacy system, you ensure that the data is classified and owned the moment it enters your modern analytics environment. Pro tip: use digital watermarking for legacy files. Since you cannot enforce row-level security on a mainframe CSV, adding an invisible watermark allows you to trace any leaked data back to the specific legacy export job and user who initiated it.
Scenario 144. How do you implement and govern data contracts in a decentralized data mesh environment?
Answer: data contracts are the handshake between a domain and the rest of the company. I would implement them using these 4 components. 1. Schema definition. The producer defines the exact table structure, data types, and mandatory columns in a YAML file. 2. Quality guarantees. The contract includes minimum quality thresholds, for example. This column will never be more than 2% null. 3. SLAs and freshness. The producer commits to a specific update frequency, for example. Data will be refreshed every hour. 4. Automated enforcement. The CI and CD pipeline checks the actual data against the contract dash. If the data violates the contract, the data product is automatically marked as broken in the catalog. Pro tip: use contract versioning. Just like software APIs, data contracts should have versions v1, v2. This allows a producer to update their schema without breaking the v1 contract that 50 other teams are still relying on.
Scenario 145. How do you design governance for unstructured and multimodal data documents, images, video, and audio?
Answer: unstructured data cannot be governed with SQL rules. It requires AI-driven content governance. 1. Automated AI classification. Use computer vision to scan images for sensitive info like credit cards and speech-to-text to scan audio files for PII. 2. Metadata enrichment at ingestion. Automatically generate descriptions and tags for images and videos using LLMs to make them searchable in the catalog. 3. Vector database governance. Treat embeddings vector representations of the data as sensitive assets, ensuring they inherit the classification of the source document. 4. Usage-based access. Since you cannot mask an image easily, use dynamic blur or restrict access to the entire file based on the metadata-derived classification. Pro tip: monitor AI training usage. The biggest risk with unstructured data is that it is used to train an LLM that then remembers the sensitive info. Ensure that any unstructured data tagged as PII is explicitly excluded from all AI training pipelines.
Category 7 Conclusion.
Mastering the operational core of lineage, stewardship, and security is what separates a data librarian from a data governance leader. By automating the technical maps and empowering human owners with clear decision rights, You create a self-healing ecosystem where data is not just stored, but actively managed. A robust operational core ensures that when the business asks, "Can we trust this data?" the answer is always a verified yes. Series Part 1, the Big Picture Recap.
What we have covered so far.
In this first part of our masterclass, we have deconstructed the foundational pillars of modern data governance. 1. Enterprise strategy scenarios, moving from centralized control to federated enablement. 2. Data quality scenarios, shifting from manual cleanup to real-time data observability. 3. Metadata management scenarios, building active, automated catalogs and knowledge graphs. 4. Master data management scenarios, creating the golden record across fragmented systems. 5. Privacy and compliance scenarios, automating global regulations and AI ethics guardrails. 6. Cloud platform scenarios, governing lakehouses, Snowflake, and multi-cloud architectures. 7. Operational core scenarios, mastering lineage, stewardship, and zero-trust security. These 145 scenarios form the bedrock of any expert-level data governance interview.
The journey continues.
While we have covered the foundational and operational pillars, the most advanced challenges are still ahead. In the next parts of this series, we will dive into AI governance and Gen AI strategy, data architecture integration, and the industry-specific scenarios that will truly set you apart from every other candidate in the market. If you found value in these first 145 scenarios, please hit the like button and subscribe to the channel. This helps us continue creating these deep dive resources for the community. Your journey to becoming a top 1% data governance analyst is just getting started.
Check the description for parts 2 and 3.
All the links to the next parts, including AI governance, BI analytics, and advanced future state scenarios, are waiting for you in the description below. Do not stop now. The most wow scenarios are in the next video. I will see you in part 2.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.